Yeah, there's people still come in, so stick your head out the door and tell them lunch is finished. Sorry, yeah.
So yeah, kind of your limit is here. If you go further
God.
off it,
I will wonder about it. I know I do. Tell them to stop it. You just keep pointing at us. I'm guessing, yeah. I don't think there's any video thing that's ever been improved with having my face in it, so probably better if it misses me. Boom, 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 boom.
I think we'll go if everyone's ready. Yeah.
Yep.
Okay, so welcome back. Thanks very much for your attendance this morning. I'd like to introduce Brian Emery from the UK Hub and Checkout Solutions.
Yeah, thank you very much. Thank you for coming back. Hope you had a good lunch. So this is a talk, an awareness talk on a combined collaborative standardization process we're going through with the industry, and that's the oil and gas industry. So I'll give you a little bit of history. 2.5 years ago, when there was a sudden fall in prices of oil and projects stopped, there was a bit of a issue in the UK oil and gas industry and sustainability and how we're going to survive this. And we went through a process of looking at how closely we're linked to the price of oil and gas in the UK oil and gas industry and its peaks and troughs. We follow it very closely, in fact, more than any place in the world. When the price of oil goes up, everything goes up. Prices associated goes up. When the price goes down, everything comes down. And it's very unsustainable and difficult to live with. So I was chair of a committee of Oil and Gas UK to look at these issues and problems and look at some potential solutions. So we had 3 months of working with a team of industry people from all different disciplines and departments. We looked at our industry, we looked at outside our industry, and we looked at what we were good at and what we weren't good at. And to be honest, as far as supply chain and business efficiency goes, it was more than what we aren't good at. The way the oil and gas industry works is dissimilar to other industries. We are incredibly motivated on 3 stages of operation. The project phase, which is all about speed. You're not making any money in project phase. Build, CapEx. Operations, where you make your money, and then divestment or decom at the other side, which is where you don't make any money. So everything's focused in this area in the middle, and the rest's about speed and maybe safety. So the biggest issues we found against other industries is we don't collaborate and we don't standardize. We don't look for standardization, we don't help each other, and we don't collaborate on basic, simple things that other industries do. One of the best examples was someone spoke about in aviation about a flight. It's going to Changi Airport in Singapore, and a red light comes on, and he radios ahead, he lands, there's something waiting, a part waiting for him, it goes in, he turns around and he's off again. That could be a part for 15 different aeroplanes and 13 different companies. Really doesn't happen like that in oil and gas. So we tried to look at some solutions, and this is it. This is this fantastical technical innovation. Yeah, it's about as complicated as it gets. The complication is involved in people and getting companies to work together to get rid of this nonsense about competitive advantage and standard equipment information. It's crazy. Yeah? So the discussion around collaboration and standardization was to create this, which is the UK Hub Digital Data Exchange. And the point of this is to collect information once and share it. And that sounds so blatantly obvious, you would think, why hasn't this happened before? And that's what everyone says. The ridiculousness of doing this inside several companies is only defeated by the fact that we do it inside our own companies. One oil company. Between assets, they don't share information. So you will have a position where you procure something in a package. And the package, supplier goes to suppliers, goes to manufacturer, and comes back again. And by the time that information's back, all the information required to support that, the documentation required to support that equipment, you could have collected it 16 different times in different ways in different parts of the project. And that information goes through a process. So, the data exchange. Simple things. Luckily, it coincided with something called CFOS. It's a ridiculous acronym I won't bother you with. But it means standardizing what they call VDDR. That's Vendor Data and Document Requirements. So when you buy something from a supplier, typically you'll ask for something to support it. And that'll be certification, it'll be drawings, it'll be spare parts lists, it'll be whatever it is that you need for the life cycle of that piece of equipment. So this is now a standard RDL. RDL means Reference Data Library, and that's built in the class. So you have a class of equipment, this is valve. And for valves, we require these 18 attributes and these 6 documents. And we'll agree on that. It's not everything we'll ever need, but it's enough for us to actually know what we're speaking about. And actually, if we uniquely identify something by manufacturer name and part number, not supplier number, not serial number, manufacturer name and part number, then we understand what we've got. At that time, they also tried to run a surplus stock trading initiative between the companies. And they took all their material masters and they put them in a big place together and they looked at them and no one called anything the same thing. No clue at all. They tried to trade something and they spent so long trying to decide if that was actually what it was they needed and do we have the right documentation to support it and whatever. It was just, it didn't happen. So it was basically us trying to start the process 2/3 of the way down. So we're looking at this to uniquely identify things, complete spare part lists, and an audit trail of upgrades and replacements. So that's important. When you buy something, you may be told that's no longer exists. It's not what it is now. It's now this. But you have to have somewhere that tells you this has replaced this, because that thing there might be what you've got in 16 of your assets. That's what you're putting now, it's new, but that might be what you've got in your assets. And you need to be able to manage spare parts list and inventory across that, and you need to be able to follow an audit trail of these things. So we're hoping to support. The one strange thing is when we went through the wireframe of this and we said, what we're going to do is trade stock between each other, because we've all got surplus entry, because we've all got duplication in our material masters. So we've got, I wouldn't dare to tell you how much money is sitting dormant in warehouses at the moment in surplus inventory. Hundreds of millions of pounds. So the surplus stock trading sounds like a great idea, except there's 99 sellers and 1 buyer, maybe. Nobody's really interested. They want to get rid of their stock. So we thought, sort the problem. Maybe not stock trading, it's maybe shared single inventory. So in commonly bought items, what we can do is, now we know the same language, now we're calling something the same, and now we have the same requirements for document and data, we can support, you need 50, you need 50, you need 50, you need 50. Or maybe you only need 100. And we can look at, and that inventory can be virtual, it doesn't have to be physical inventory. And faster procurement and reprocurement. I'll go through that in the ROI in a minute. And also, these things always grow arms and legs quickly. We've got this thing now, we're filling it up with information. What can we do with it? So the asset integrity guys and maintenance systems guys are saying, fantastic. So I can be off on there, I can look at a serial number, I can press a button, and I can have a blow up, a drawing of that. I can have the spare parts list, I can have everything I need like that as I'm looking at it. The procurement and ERP functions have clear language between the ops guys, them in procurement, and the supplier. Because, again in ROI, I'll explain the difficulty we have in maintaining that information. Engineering systems, running POC at the moment with BP, where they will have all documents and information out of their engineering systems. They'll sit and be maintained separately, and ERP will feed off it through APIs. Engineering systems, you'll be using your engineering system, you'll press a button, in comes the drawing. Doesn't matter where it comes from, the end user doesn't know, doesn't care. But the integrity of that information is being kept and maintained in one place. For suppliers, I thought it was going to be an issue, because we're going to say to suppliers, you're changing the way you do this now. Normally, we'll say, this piece of equipment, we need this information, these attributes, these bits of documentation. And you'll get 5 PDFs, 3 spreadsheets, and whatever else, and it goes off in the project route and disappears into wherever it goes. So now we're saying you're going to go to the data exchange, and it's really prescriptively going to say to you, this is the class, this is the piece of equipment, put these 4 documents here, put these attributes here once. That's it. And we'll share that between everyone. You won't have to do it again. And what that solves for them is that the data and document requirements are clear, because typically what you'll get is a conversation. That's not the document I wanted, or I need this, or I need something else. If it's clear, then the chances are that that fulfillment's done quickly, which means a supplier gets paid quickly, which is the most important thing for a supplier. And it's a marketing thing. There's a potential of 41 owner-operators looking at this system. So I would rather have my information in there than not. Purchasers, so they've got access to all this uniquely identified information. If they want company-specific, so any assembled items, anything that might have IPR, they can do that in silos. They can not share that, but we're really furiously protecting against that. Anything assembled or engineered generally will be made up of equipment, which is generic equipment, and can be kept at a lower level hierarchically and shared. Industry standard class library if they don't have it, which is the CFOS, and the data exchange with the APIs into their existing systems. So it's going to be incredibly collaborative, incredibly open source, and it will speak to anything and everything. The ROI, so we went through lots, and I'm not expecting you to read this, sorry. This is just to say that we've been through lots of scenarios, and it's saying here that missing and incomplete information makes up 30 to 50% of equipment items in an inventory list or in a master register will have not the right amount of information, or will have incomplete information. And the reason is, I go back to the package supplier. When you order something, the package supplier goes to a supplier, goes to a manufacturer, and that manufacturer has a part number and a name. And by the time it comes back through the project phase, it's got three S's, 4 hashes, and a Q at the end of it. And then it goes into SAP and disappeared. It's useless. It's nobody's job to maintain that, really. So it's about taking that information out there and uniquely identifying and keeping it somewhere else. 80% of the physical tags and assets are standard off-the-shelf items. People think, oh, we're going to share this information. This is in our best interest. 80% of this stuff is available in Google, if you've got the time, if you can be bothered, which no one has. And also when it goes through, the miscomprehension is that data is just supplied, and then that's fine. It's ticked a box. It doesn't. It goes through a process every time. It goes through. In my day job, I work for a company called ShareCat. We do the information management systems for Shell's mega projects and BP's mega projects, Tangguh, Kazan. And we have these incredibly extensive workflows that get this documentation through different routes, through engineers, through everyone else that needs to see it in order to get through the authorities process. So that's a huge, huge headache. And all these things are leading to thousands and thousands of man-hours that are unnecessary. And the last one, so this is the procurement. If you don't have the language right, and what this guy's asking for here, and what your procurement people have here, and what the supplier's understanding here, if that goes back and forth 2 or 3 times, that's just unnecessary profligate to duplication of effort. Which means if you've got that information right, and it's uniquely identified, and you can reorder in one time, you can save, we're into the hundreds and thousands of man-hours across the industry now. Where we are, okay, so the early adopters we've been working with, the participants, major oil companies, some of the tier 1 guys have been putting their input in. We're getting pretty close now. There's going to be a launch event, which I'll tell you about at the end. UK Hub, which I'll tell you in a minute, is not for profit. It's by the industry, for the industry. It'll be, a team will be formed, it will run independently, but will be governed by a steering group, an oil and gas steering group, and it will be not for profit. Any money it makes will go back into the system to improve it. The technology readiness is there. I will say, I'm not completely altruistic. It's my technology, it sits behind it, but we can be kicked out if we're not performing, and it's in the contract. Our job will be to help that UK hub move to another provider if necessary. And the industry awareness sessions we're running all the time, and that's workshops and work groups and awareness sessions like this just to let everyone know it's coming. Again, just to go through the cost savings, massive, massive duplication of effort, ridiculous duplication of effort, continually collecting and processing all this information. The procurement and reprocurement, combined inventory of commonly bought items, increased communication through the language in the supply chain. And that's really important, even through your contractual supply chain. So the owner-operators through the contractors to the suppliers needs to be tighter. The language needs to be better. Not for profit, as I say. Steering group at the moment, so Association Oil and Gas Technology Centre paid for this. We had discussions with the steering group members, and they said, is there any money available for this? We went to OGTC and said, yes, this is important to us. This is part of our digitalisation process. So here's some money, go and get it built, which it is now. These are the guys who have been contributing data and expertise and engineering knowledge and everything else we've needed as we go along. It hasn't been restricted to them. We've gone out to wider groups because we had to, including suppliers and logistic companies and etc. It's growing arms and legs, always does, always will. When the people see this fantastic bulk of information they've got now, clean, maintained, validated information. So I said about the engineering systems, now looking at 3 and 4D design, where you can actually start building using physical attributes as opposed to functional. It's typically what you'll do in your 3D, 4D design is you'll have an idea of what it's going to be. This is the specification it needs to be without actually knowing what that is. It has to have this pressure bearing, or it has to have this dimension, it has to have whatever, and they build the 3D model. And then they agree on it, and then they go off and purchase it, which is a massive, massive chunk of time. Because if you have all this information, you can actually look at the physical pieces of equipment that fit the attributes and start building in real time. AI machine learning, we're making big steps forward with that because there's a lot of data to be collected, and there's a lot of our systems currently do this, but not as well as they could. If it comes up and it says, this is a piece of equipment for Emerson, here's the part number, our system will say, no, that's not right. We know that. We know that's not an Emerson part number, and kick it back and do whatever. And there's a lot of effort going into the AI. Internet of Things, we're speaking to the SAP Innovation Centre about that. I'm not dismissing it, it's just that's much further on, I think. And big data analytics, this is a hugely important thing for the cost sustainability. We can start looking across the entire industry. What's falling over, what's working, what's not working, what is a better life cycle, and really starting to improve the value of the supply. So, as I said, arms and legs. So I was in Houston 2 weeks ago, and some of the majors, including a couple of others, Exxon and Chevron, whoever else, have decided this is what it needs to be. And I agree. It has to be. The more input, the more it's shared, the bigger the savings, the better it's going to be. So we're working towards this now. I've been pretty strict in that there needs to be proof of concept, and proof of concept will be UK. That's where we're going to kick the tires. We're going to make sure that this model works 100% solid. And then these guys, the oil and gas industry, have taken ownership. That's absolutely fine. They have big agreements with multinational suppliers who will bucket load, will bulk upload all sorts of information into this. But that all has to be validated, has to be maintained, has to be kept checked, has to be audited. So, I mean, it's a big job. So there will be a huge team looking after this at some point in the future, somewhere, probably Houston. And then we're speaking about, a compressor's a compressor. So heavy industries, the chemical industry, the regions, everything else. As long as we can force this standardization, then we'll make this something that's really going to help the oil and gas industry. Literally hundreds and hundreds of millions of dollars in the UK, it's estimated. Globally, who knows? We're not trying to sort every problem, but the oil and gas industry has problems in supply chain, has problems in procurement, has problems in collaborating, has problems in standardization. And this was one of the solutions that was put forward, and we've actually managed to get them to move towards it. So when you see the UK in the 24th of April, there will be a live presentation demonstrating the hub, showing you the content during. That's at the Aker Media building in Dice. It's free, it's open entry. If you're interested, you'll find details of it on the website, however, come along. The owner-operators will be there, Shell will be there, BP will be there, and they'll stand up and tell you about their digitalization, transformation and modernization programs, just the buzzwords, and how this fits into it and how this kind of underpins it. As I say, it's not rocket science, it's not the smartest thing in the world, but if these guys can come together and use it properly, there's a chance it can make a difference and hopefully help prolong the UK oil and gas industry. That's it.
Thanks very much, Brian. We've got probably about 2 or 3 minutes.
Okay.
Have we got any questions on what Brian said?
You mentioned that the ShareCat technology
Yes.
is running behind it.
Yes.
I guess it's one for how do you ensure if the industry is investing in this process, how do you ensure that this sort of uptime, and then there's a security aspect of it. There's quite a lot of data into this. Yeah, there's almost a vendor, if I understood it correctly, behind this. So I'm just trying to understand.
Absolutely. I mean, we've and this is probably at one point through this process, I was, what have I done? Jump through hoops is what we've done. It's everything in it, associated with it, the data centers, everything, and it's been funded. I mean, people are helping us get there, and it's not specifically for the ShareCat company. It's for the future proofing of the. So it's all ISO 27001. It's all everything it needs to be to support this at this stage. When it goes off and becomes the global thing, then I'm fairly sure that will be taken out of our hands. The core structure of the technology will probably remain because we have IPR in that. And that's pretty evolved over 25 years. So, I mean, it is the right tool for the job at the moment. It's not to say it will be in 5 years. If I was another company in a similar synergist kind of product, I would be looking at how I'm going to get into this. So, I mean, I'm not expecting it to be unchallenged, but I still think it's worth doing.
Percentage-wise, how much would you say is complete of that process? How much have you got to do?
For UK Hub, we have a fairly hard launch deadline of the end of the second quarter this year. So the data's in, it's being validated, it's a process we go through. The main issue at the moment is the RDL. The CFOS RDL is not complete, so it's a combination of our RDL, which is 20 odd years old, developed with industry, and CFOS. And what we're going to do is feed live information back into CFOS to help create that RDL and make it. Yeah.
You feel that's achievable?
Yes. Yeah. I would say we're probably 80% of the way there. And the only issue now is making sure that the guys who are supporting this step up to the plate and put their work where their mouth is.
Okay, well, thank you very much for
no problem at all.
An excellent presentation. Very much appreciated.
Okay, thank you.
You've probably forgotten you've got it on, but have you just...
Oh, yeah.
And if I could introduce...
Nope. Sorry.
Angus 3D Solutions, who's obviously not here by lots of things. Is that... Could you? That would be great.
I could leave this on, you can listen to me singing in the car as we go.
We were promised some operatics from Fredrik Tukk earlier on, to be fair. Just in the nick of time, Andy. Yeah, of course.
Okay. Printer, that one?
Yeah.
And you've got the present, you've got it,
Okay. Okay, good afternoon. I'm Andy Simpson. I've got a business in the big city of Brecon called Angus 3 stand across there. 3D Solutions. Thank you. Cheers. I'm going to start with talking about innovate. You know, looking up the dictionary, I think it's important to start with looking at this. What does it actually mean? And the key word in there is change, you know, make or become different. And hopefully I'll talk about how additive manufacturing can do change or innovate, okay? I'm going to start off with, here's an extract from an email, and it starts really well here. Very promising. This is a person who has the title of innovation in their job title. Starts off really well. You know, they want to look at 3D technology, additive manufacturing, but they spoil it at the very end by saying, we don't want to be first, we want to be a close second. That's typically of what we're finding with this technology in the oil and gas industry. Nobody wants to be first, everybody wants to be second. Okay? And that's a big challenge of if we want to drive innovation in the industry, and particularly using this technology. Hands up. Hands up who's in a sexy industry. One gentleman. Absolutely, there we go, okay? This is us, right? We're very traditional. We're very traditional in Scotland, full stop. Never mind being in the oil and gas industry. We're very traditional, you know? It's weld stuff, it's machine stuff, etc. Sexy industries innovate, right? If you're not a sexy, I'm talking about sexy. What do I mean with that? I'm talking about these companies. I'm talking about these companies because they really understand the word innovation. They don't use it just as to title a job, a department, or give somebody a job title. They're looking at ways how they can implement change all the time. Formula One's a perfect example, right? It's a new product every single year, or every season, and changes through that. Always looking. Key focus, take risks, looking at how they can learn from their mistakes as well, which is something that we're very, very scared to do in the oil and gas industry. Aerospace, medical, automotive, and obviously space. Does anybody think that these industries have got a lesser risk than the oil and gas industry? No. They've all got their risks. Put it this way, a plane falls out of the sky, or somebody's killed in a car, or recall, or anything like that. It's bad publicity, whatever way it is. Okay? They're not any different than the industry that we're in. So, we've got to start thinking about the oil and gas being sexy, right? If we really want to be embracing innovation and doing things different, we've got to start thinking about being sexy. Additive manufacturing, or formerly known as 3D printing, will help us do that. I genuinely believe it's got a place in the industry, and it will bring change to the industry. However, the industry has to change. We must start being sexy and look at things of how we can do things differently rather than just the same. So, if we look at some of the other industries, have we got complex parts? Yep, we do. Okay, it's not any different than the aerospace. We should be looking at parts that are complex and saying, how do we manufacture them slightly different? So we're reducing the amount of parts, so we're consolidating parts. Instead of building 5 parts, how can we redesign that and reduce that down to one part? An example would be GE Aerospace, take 6 parts in one of their jet engines, reduce that down to 1 part, and it saves their customer $1 million a year per engine. If we could come up with that in our industry by making a slight change to the design and save $1 million in that quantities, I think we'd get a pat on the back, a lot of us. That would be the true meaning of innovation on your job title. Customization. We're an industry of where we customise things for whatever particular operation it is. Okay? Medical do that all the time. Okay? We're looking at making parts for specific jobs, etc. So customization, there's opportunities there of customizing parts one-off, so it doesn't necessarily have to be standard. But because it's not standard, it doesn't have to be over expensive as well. Consolidation, I touched on that. Bringing a particular part like this, GE, reducing that down to 1 part and saving a huge amount of money because there's less risk. 5 parts, I've got 5 lots of seals, 5 sets of nuts and bolts, keeping it all together, 5 parts that can fail, etc. Reducing that right down to 1. We're getting into here, obsolescence. I've seen an increase in that. If one thing positive of the downturn is that people are starting out looking at equipment and going, hold on a second, what's actually wrong with this? And they're now seeing it where we can actually reverse engineer, manufacture replacement parts and keep assets in the field longer. But they don't have the original drawings and that. So with 3D scanning, 3D printing, we're starting now where we can take an obsolete part, reverse engineer that and keep assets in service longer. It's one of the main benefits of it. Manufacturing location. Yeah, the world is getting smaller. However, let's not talk about the B word, but things are going to be potentially getting difficult to move things around countries as well. It takes longer, etc. So instead of having centres of excellence, and where it comes to manufacturing, why don't you just move the manufacturing to the location that's needed? Be it outer space or offshore, where we start looking at say, how can we manufacture replacement parts or consumable parts at site of location? What we're doing now is instead of having inventory, we're having material and a machine. That material is suitable for printing various components. So we're all of a sudden now reducing our lead times and spares. Traditional manufacturing takes about 6-8 weeks, usually on average, to get something manufactured. And additive manufacturing in metals, you're getting that down into the days, 6 to 8 days. So if you could turn that around and knock off the weeks and turn that into days, what's the financial benefits to you by being able to do that? Some of the benefits, if you even go back to the plastics, printing off plastics, if an engineer wakes up in the morning, has a great idea, and he can quickly turn that idea into a physical part that he can show a layman and communicate that very, very quickly, there's huge benefits in that, where they can actually go and say, this is possibly going to do what we actually want it to do, and we can communicate that to other people that may not be as technical. Formula 1, learn more out of their failures than they're out of their successes. So being able to print parts off, test them, do all that, do the modifications before you put into production, and you'll land up with a product that is actually better or closer to what you're actually looking for. Time, I've touched on time. 8 weeks, 8 days. Yeah? Big, huge benefit of that. Not just because you've got the product in your hand, but if you think that and turn that into inventory levels, where I can turn around and say, I don't have to keep inventory because I can get it in 8 or 10 days, which meets my plan, then I don't have to hold spares, inventory, etc. Always keeps accountants happy. So you reduce your expend. Okay? I've got customers where they're paying more for the individual item. However, what they're saving on inventory costs, warehouse costs, and people moving that about outweighs that difference. So instead of looking at unit price, looking at the whole supply chain cost as well. When your product goes into assembly, because let's face it, your part may not necessarily be additive manufacturing, it may be traditionally manufactured. If all this has been done up front, you can guarantee when it goes into assembly, your engineering and rework costs, being a manufacturing person, every manufacturing facility has a hidden factory. That hidden factory inside it is what nobody talks about. It's where all the reworks go. When things go wrong, because nobody wants to talk about, well, we've done something wrong. Who pays for that? Nobody wants to pay for that. Is that engineering or is it manufacturing? Nobody wants to pay for that. It's a hidden factory. That disappears. And that can only result in better results. Your product is closer to what you actually want rather than a product that is used as is. Okay? Quality. And it all filters through where you've got a quality product. I'm going to touch on just a circular economy. I don't know how many are familiar with the circular economy. The reason I mention that is because some of the technology I've just brought in, one metal printer I brought in, it's the only one in Scotland. It's the only one in the UK that's commercially available because the rest of them are in Formula 1 teams and universities. And that was done by, granted by Zero Waste Scotland. I got a fund for that, so I need to mention this. And it's down to the circular economy, is where if we start looking at this particular area in this industry, where we start looking at remanufacturing and using this technology to we put stuff back into life, extend the life of that, and that can only be good. And the other area is, if we adopt this technology, is start looking at things at the design stage. It's very hard to get design engineers to change their focus from traditional manufacturing. If you go back to your engineering departments and they say, one thing you've learnt about additive manufacturing, weight. That's the secret. There's nothing else. If you can get your design engineers to think about reducing weight, that's the secret. A lot of companies will turn and say, Andy, I don't need to reduce weight. I would say, you do. Weight is money. If you can reduce that weight, the component will have less material, it's fit for purpose, it'll do the job, etc. It will be cheaper, especially if you've done complex components. So Scotland has an impressive history in manufacturing and engineering, right? And I genuinely believe if we need to keep that reputation, being a manufacturer and being involved in the oil and gas industry where we tend to shut down manufacturing facilities and ship it overseas, we need to continue doing the sexy stuff, the high-tech end of the stuff, the business. Not the widgets, the high end. And if we continue wanting to do the high end, we've got to start adopting the high-end technology. Okay? Especially if you want to attract this next generation of people. They don't want to work in an industry that is basically, as he says, he pulls it, sorry about the mic here, pulls out an example, sorry, where it's an industry full of dinosaurs. All right? We've got to get that sexy image or sexy part of it rather than what's seen to the next generation as dinosaurs. That's me. Quick, don't get me wrong, I could talk for hours on this, and 20 minutes is an extreme struggle for me to keep it in there, but I think I'm within that. Got a few minutes? Good, that's a first. So you got any sexy questions? Not plain questions, sexy ones. Sorry.
No, it was interesting what you said. Thanks for the presentation. Just wondering what the main barriers to adoption are. Is it this fear of failure? Is it the fast follower, like you said? We'd like to be second, we'll wait for somebody else.
That's what it is. That's really what it boils down to, is that nobody wants to step forward and say, right, let's drive this industry. And as an industry, I genuinely believe a company on their own is going to struggle to do that. And what I've experienced this past wee while is it's actually smaller companies, and it's usually 3 or 4 guys that have been made redundant, have got a good idea and they're going to try it. They're more aware of this technology. However, if you get some of the companies together and, I don't know, go to the likes of the Oil and Gas Technology Centre and voice that concern, all of a sudden now, you're going to get people together and saying, right, okay. And then these manufacturers of these equipment and machines will start saying, hold on a minute, this is an industry that we should maybe start listening to you. Some of the makers of this equipment go, we're not going anywhere near the oil and gas industry. They're full of dinosaurs, they're hard to work with, they're a pain in the butt. And secondly, we can get, and this is a true fact that they said to us was, we can get more out of one order out of BMW than we can out of all the dinosaurs in the oil and gas industry. Don't get me wrong, that's great for me because my background is oil and gas. I've got a pool that I can go and tap into, and hopefully as that develops, I get the benefits of it. But the industry of additive manufacturing are going, why should we push it when the industry is not really pushing it? So if the industry puts the demand there, all of a sudden the rewards will come in and you'll have the Lloyds and the DNVs and all them putting in the requirements, etc., very, very quickly to satisfy the needs if the demand and the want is there. Just the same as the aerospace, the automotive and the medical industries.
And are you managing to convert some of this dinosaur thinking?
Yeah, I'll be honest with you, if you go to the operators, etc., these people there, the gentleman stood up in front of all the suppliers, presentation, 3D print spares, And that was the response. We go, oh yeah, I know that's what I said, but I'll be second. Okay? You know, so however you go to some smaller companies, and there are a few, believe me, there's a few in Aberdeen here that are working on little things, and you go, oh my goodness, this is really, you know, innovation to its proper meaning, and they're pushing the technology of additive manufacture further, in some cases, than what some of the aerospace. We've got companies that are taking that and expanding it, etc., and seeing what it does, and that hasn't even been done in the aerospace. And we're talking about 3 or 4 guys going, let's try it. Give it a go.
Excellent.
Okay?
Thank you very much.
Thank you. Yeah.
There's a microphone as well.
Yeah.
All the technology. Thank you very much. Good talk.
I'd like to introduce Gary Paynes from EDR on the desk.
There's the clicker. So we've got a few people coming in. 2 questions. How many people are in an organization that has intentions to do digital transformation or digital twins? 1? I'm talking to the wrong audience. How many people actually have a real plan in action? 1? Excellent. 2? Okay, well, maybe there's a few people. So, do we have... There we go. So the talk today, this is part of a longer talk we do as a breakfast session, but I've tried to condense it into 20 minutes, so I will rattle through. So if you've got questions, catch me afterwards. I'll probably use all 20 minutes. Okay. So hype or plateau technology. I'm just going to talk on those topics, but going through, just going to talk a little bit about IoT and digital twins, the business of it, emphasis on the word business, our specific take on digital twin, which is predictive maintenance and predictive capabilities, how you go about building one, our experience in that, and some industrial examples, and then a bit of a conclusion at the end. So one and a half slides on digital twins and the whole business concept, if you like. So this isn't oil and gas. We've got plenty of oil and gas later, but this is just an example. If you look at this setup, this slide, on the left-hand side here, you've got sources of data, patient, diagnostic devices, wearables. In the middle, generally speaking, you've got data, processing data, and storing data. And on the right-hand side, you've got a whole bunch of ways of using that data. And I prefer this. I've overlaid the original slide here. This is data and technology, and this is the business model. And that's the separation I actually want to sort of focus a talk on, is the difference between those two things. The hype. We've been looking at this, our innovation chief has been looking at this for about 5 years. We've been working on projects on digital twins using simulation. So physics-based simulation to predict the future behavior of an asset. And he got involved in trying to understand where we are on. This is the Gartner hype curves. You've probably all seen it or heard of it with something associated with it. Peak hype and plateau technology. Back in 2011, Internet of Things was just starting to appear with 5 to 10 years possible it might actually happen. I'm skipping a few years. 2013, Internet of Things is almost at peak hype now. Big data's up there. Internet of Things is now out at more than 10 years away, according to Gartner. 15, IoT platform, Internet of Things, still 5 to 10 years away. 17, first time digital twin hits the Gartner hype curve. It's still innovation. It's more than 5 to 10 years away. And 2018, so last year, digital twin, deep neural networks, and IoT platform, all peak hype. So I'm here to talk about a lot of stuff and nonsense. And this runs contrary to the fact that for 5 years we've been working on this. So we're kind of interested in what is the difference between the two. And that's really the talk today. So why is it still at peak hype? Here's a simple thing. You have an asset. You can connect sensors. You can go to the RS catalog and get a GPS, GSM connectivity. There are so many IoT platforms that you can't even read the names on this graphic here. This is all commodity technology. The bit that's causing the problem, I would suggest, is the applications and the business case at the other end. There are many, many, many different digital twins. If you go around the circle out there, you'll probably find 10 different digital twins to talk about. They're all great in their own aspect, but the trouble is, it's dispersing focus on what you can do as a business with digital twins. And this is actually we've worked with ones that failed, and some that have been successful, and some that are just proof of concept, which don't really count. But having the business model and how you present that to a customer is the critical bit between success and failure. This is from Gartner again, and really digitization, if you think about digital transformation full stop, the whole thing, really it's about changing your business model and providing new revenue by taking advantage of digitalization of your process or something. Now, we're not here to boil the ocean. We're experts in computational fluid dynamics and stress analysis and all sorts of funky stuff like that, basically engineering simulation. So for our bit of it, we focus down a lot more. But coming back to, this is actually Frodo, based in our Oslo office, spent a lot of time studying and looking into the background of this to try and make our project successful. And this is an interesting couple of observations. So you either have beginners, so this is leadership. This is like business acumen. How much business acumen is going into this project? And this side here is how much technology, how much tech, how much digital tech is going in. Now, fashionistas, heavy on tech. This is fantastic. We've got widgets and bells and everything. I would say the oil and gas industry actually lives down here. We did this presentation a little while ago, and everyone said, oh, yeah, that's us. So pretty good business acumen, understand what they're doing, probably a little conservative in the business outlook, and really not cutting edge on technology. The guy was talking about being second to market with technology. That rings true quite a few times. And obviously, there's a scope up there. It's a quadrant, so someone has to win. Put some numbers behind it. This is based on this. This is a 4-year study of a whole bunch of companies that fitted into this, with this being the sort of average point here. So the fashionistas are able to generate revenue. They're growing quite faster than average. Digital masters growing faster than average. Conservatives growing less than the average. Okay, that sounds a bit confusing and probably sounds a bit insulting, as I've just said the oil and gas industry are down here. But actually, when you look at profitability on the same group and comparing it to average, these guys are doing better because they've got a good business model. They're maybe just not making the most out of it. And obviously, these guys have got a good business model and they're making the most out of it. So there's a real business drive here. You know, the difference between a good business model and not a good business model is 37% difference in profitability. And if anyone's making enough that they can swallow that up, then I'd like to join your business model, please, because that's quite a big difference. For us, I said earlier, we can't boil the ocean. These are all the sort of elements. You can transform your customer experience, operation, or your business model. The bit we focus in for engineering simulation are these bits. Your process digitization, so how you build and design things, and then the digitally modified business and opening up new business models. And I'll share some of those examples with customers who led from that point at the end. Sorry I'm rattling through this, but there's actually nearly 40 slides for 20 minutes, so it really has to be that fast. As an engineering simulation provider, services and software, whatever, this is what we talk to people about. Digital concepts, digital prototype, digital manufacturing, and the ultimate embodiment of that, capturing it all, is digital twin. You don't have to do all of these to do one of those, but you need to do everything to do one of these. When we look at that, basically that is taking the business model and building on top of all the technology for this, and specifically predictive maintenance. When we look at companies that do simulation, I'm not going to stay on this slide for very long, but at the bottom end, and quite a lot of companies are here, the simulation they use is project-led, case by case. The person who owns it is probably engineering on a project. When we look at digital twins, this is a business-led initiative. This isn't being driven by the engineering team. They're probably scared witless by it. It's being driven by somebody at a very high level saying, this is how we transform our business. If that's missing, then your digital twin initiative isn't going to work very well. So what's the difference between predictive analytics and condition-based analytics? There's a lot of condition-based analytics. Had some good conversations around the quadrant out there again. Really, what you're doing is gathering data, doing some pretty complex maths on it, often with artificial intelligence, and you're understanding the health of the asset. At its simplest, this is a sort of traffic light, green or red. There's something right, there's something wrong. Taking all of that and building onto it, using the physics-based models that you designed the product or the asset with in the first place, and then fast-forwarding its life using those predictive tools based on real modeling data, real engineering data of usage. And that's the difference. And I'll come expand on that a little bit. So what you have to do, and this could be condition monitoring, so you have to decide what the use case is. You know, you can't just randomly decide what you're going to do. You have to base it on some sort of failure mechanism or some sort of life-limiting criteria. Then you have to gather the data. You have to work out what maths you're going to do. You have to bring all that together. You have to do something called filling the data lake, model it, and then you have a product at the end which tells you something. If you're basing stuff on data you've collected, you've got to collect the data. Rolls-Royce have got years and years and years experience with jet engines collecting data. Filling the data lake can take a long time. You can only predict a failure if you've spotted that trend over multiple failures in assets. Then you can go right back to the start and say, this was the first point at which that failure was visible. You need a statistically valid number of failures to do that. That makes it very difficult if you're doing low volume or one-off assets. By contrast, if you're using the sort of simulation-based tools that you design these products with, especially often for one-offs like nuclear reactors, they're all designed using simulation. Same, you've got to understand the use case, how or where might it break, you've got to collect the data, basically put the sensors on to collect the right data. But then you can start generating data, and we've got some fairly slick tricks, which means that you're now down to weeks instead of years. And I'll show some of that in a second. It's the only bit of technology in this presentation. And then the same thing at the end. You've still got to implement it, got to handle it, basically look after all the data, and you've got to publish it in a way that you can make a business out of it. Oh, there we go. Oh, back. Sorry, there's a slight lag on this. This is what we do mostly for a living. It's digital prototype. If you remember my digital lab thing, it's the one in the middle. This is where you do high-fidelity simulation. It might be fluids, it might be structures, it might be electromagnetics. You can bring it all together in system modeling. And you can model something, model its behavior using accurate physics models at an incredibly high degree of accuracy these days and fidelity. Computation has gone through the floor in terms of cost. There's more compute power on my iPhone by a long way than there was in the computer I did my research on. You know, it's just crazy, and it can be used. And the software has improved massively as well. But what happens is you design something, and then often you put this work to one side. Right, it's done now, we've tested it, archive that. Well, why archive it? This is the point here. You can reuse these models. For this ROV, if you're just using condition-based monitoring, basically it's traffic lights. It's got too hot somewhere. There's too much vibration somewhere. The voltage on the battery is suddenly dropping. Game over, bring it to the surface, abort. If you're doing a digital twin, you still get those same sensors, but then you can run this into a model and say, okay, well, how will this behave over the next half an hour? Do I need to abort, or will the battery actually last all the way? I can still do that cycle and bring it up. Is that vibration important? Will it perform if I shut one of the motors down? And there's a fundamental difference there in the predictive ability rather than the just what is it doing at the moment. This was the very first one we did. It's about as simple as you could get. We did it just to understand the technology ourselves. We've actually done it 2 or 3 times because we got it so badly wrong. This is just an accelerometer measuring vibration on a compressor. That could be any bit of kit. We gather the data, it switches on, it vibrates, it switches off. We put it into an ANSYS model of that structure. Wasn't very sophisticated. Then you say, okay, well that was 1 day. What does 3 months look like? I can just stack the data I have. I can predict forward using that. That's what this one is seeing in that condition with that piping mounted to that rigid floor. That's what that one is seeing. The simulation gives me this amount of damage. That gives me some data. I then write a website, and then suddenly you've got an asset condition portal. This asset has got 12 days to the next service. This is the damage. This is the accumulated damage. the job we did last week has taken 3% off the life of this asset. What the hell went wrong with the job last week? You've suddenly got something which is valuable, coming from a predictive ability to say what's gone on. And the way this works, and this is about the only technical bit in here, you take a high fidelity model. It can be fluids. This is electromagnetics. It's a model of an electric motor. Doesn't really matter. You use that to train a neural network, which reproduces this at an input-output level. So if you want to know what the magnetic flux is here, you train the neural network with this high fidelity thing. It takes a long time, and this will give you the same answer. You put this into a system level of the whole thing. You then compile that into a runtime, and suddenly simulation that was taking days, weeks, or months to run can be run real time on a relatively light computer, i.e. something you can put in the cloud. So now you can upload usage data and get answers out instantly for your use case. And then you have to publish it somewhere. This bit is one bit of software. This bit is another bit. The only, we're an ANSYS reseller. All of that, since we started, it was a whole bunch of sticky string and sticky tape and string, but they've turned that into a product now because it's becoming more mature. We've worked with 5 or 6 different platforms. We prefer this one. But the important thing is it has to be able to take your data, add metadata to it, the ability to add data to it, our simulation data, organize it, and then hand it out to be published, basically. That might be a set of AR goggles that you're looking at an asset with overlays of damage on, or it might be like we showed you, a web portal. But the ability to do that, the thing we've learned in doing this is the technology is all there, but you really have to be careful where you stack it up. Using the right tools is the difference between it being sustainable and maintainable. Using the wrong tools, a bit like our simple first example, we did it 3 times because we used the wrong IoT platforms, and it all went pear-shaped when we needed to do something different, so we had to rebuild it again. Well, that's why you have your own proof of concepts. Some use cases, and I've got a few minutes left, so that'll be okay. This all sounds a little bit vague, maybe, but we have done a lot of these now, and not for small companies. So one of the first ones we did was this project called Sysmon for Grundfos. So Grundfos, largest manufacturer of pumps in Europe, very nice company actually, trust-owned. When they looked at, forget your central heating pump, which you've all got, one in your house, but if you start looking at high-value assets that are in a critical environment, they might be pumping, well, I don't know what they're high critical assets. Grundfos looked at this and said, we only get just over 25% of the revenue by selling the pump. The rest of the lifetime revenue that is associated with that pump is on servicing. So how do we own, as Grundfos, own the full lifetime revenue of this asset? So there's a 75%, that's 300% more revenue associated. That's a business-changing, business-led decision. Okay, we sell pumps as a service. How can we afford to run pumps as a service? We create a digital twin. The cost of your monthly subscription to this pumping is based on what fluid, what volume, and what 99.xx reliability or availability does the customer want. And then you can plug that into your system and you just monitor it now. So you're now taking the assets, a bit like our compressor. There's only relatively few things you're monitoring. Every day one of these uploads to the cloud, and you look at the daily usage, and then you can start saying, well, they've not been used much this week. We don't need to go in and service them next month because they've hardly been used. Push the servicing back a month. Or, my God, they've been hammered, and unit number 4 for some reason is really starting to struggle. So we need to get someone in there because we've guaranteed it's up and running. So you suddenly got a business model which is backed up by some science. A long time ago, and a slight aside, Vestas tried to do the same with power. They weren't selling wind turbines, they were selling power. Unfortunately, they didn't have this because it predated the ability to do this, and they got quite badly unstuck in a few places and went through a rough patch. Another customer that we're working with at the moment, this is about to be bolted to a ship. So we've done all the digital twin, we're just waiting for the prove-out. Rolls-Royce, or now Kongsberg, so they've been sold. Rolls-Royce Marine, Kongsberg Marine Maritime now. We have a digital twin of this complete thing built with Rolls-Royce. So we're taking their high-fidelity model of how the blades interact with the water. The critical damage to this is ice impact, and that's part of the model. So we're not talking about simplified use cases. There's a gearbox in here, albeit just changing direction. Shafts, bearings, gearbox at the top. All of those have got their own individual digital twin, which is put together in a system. Rolls-Royce didn't need to go and do a complex proof of concept. They had a business model. All right, they borrowed it from their jet engine colleagues, the Total Care program, where, like Grundfos, they're saying, we will own. I mean, Rolls-Royce might break even on selling a jet engine. They make all their money in the Total Care program afterwards. Rolls-Royce, or now Kongsberg, want to do the same in thrusters. So they'll sell you this as a service, or sell it with a service package to make sure it's up and running for you. And then this is another one in power gen. I'm afraid I've chosen examples here. There's only a few of the ones we've done that we're allowed to talk about, unfortunately, because they're tied up to business models. They get quite iffy about publishing them. But we've done hell of a lot of work on fundamental research with Voith on turbines themselves. These are hydro turbines. But in essence, this is a big chunky bit of welded kit with something vibrating in the middle. So that applies completely to oil and gas. And this is an interactive dashboard. This is a web page. This is static because I didn't want to send the video. But basically, the user can click on each of these points. Any of the welds in here, as a representation comes up. What's the condition of this weld at the moment? And you can see the behavior. And then you can start saying things like, okay, we've been looking at Atlantic weather patterns. We know there's a relationship between rain and the amount of force one of these hydro turbines sees. We can predict forward weather patterns, and we can overlay that on the digital twin and say, okay, are we okay? Because if one of these goes down, I mean, Norway, these are all in Norway. Norway is like 98% hydropower. So if they have to take the turbine down, people are going to be sat in the dark in winter. It's pretty dark as well. So there's a real business case. Again, this one's kind of internal. This is, oh my God, we must keep the lights on, rather than an external business case. But it's enabling something they couldn't do. So if we look at the takeaways from this, I've got a minute left, I think. The key technologies for this predictive twin stuff are there. It's not science fiction. It's not hype. It's there. The physics-based analytics, because you can crush really complex simulation work by training a neural network to give you the same behavior. You can turn this into a lightweight, compiled representation of your system that you can run in a cloud environment, which means it's not expensive to run, it's extremely quick, and you can start predicting forward behavior based on what you've got. There are quite a lot of these been done, so it's not fiction. The trouble is, it's the business model. Whenever we see it, there are ones we've worked with that have just failed utterly, but they failed at the business model because they thought of something that no one wanted to buy. Actually, getting the technology right wasn't a problem. It was getting the business model there. And that's, there's so many different thoughts and options and definitions. And I took out all the slides. There's a slide at the front of this presentation normally with all the different lingo, all the different edge devices and connectivity and all this. There's so much jargon surrounding this. You have to dive in to find something that's practical. And that's the key thing, practical technology that will help you deliver. So I would say, certainly for predictive maintenance, the technology is heading off over here. It's all stuff that's been done for quite a few years. There's a few tweaks in the last couple of years that have made it neat, and that's all. It's all there. The business case, there's still a lot of hype around it. The understanding in the business case is probably where the problem lies, not the technology. But that's fundamental to it. Thank you.
Thank you very much, Gary. Just very quickly before we pass over, you asked if anybody was making a digital twin before you start the speech. Does any one of those individuals have any questions on what was said?
Yeah, it's all at the beginning of the design phase. So the current theme, it's the second or third presentation. It's let's prove it on the drawing board, so to speak.
Yep.
What about looking at applying this and learning going forward for, in the North Sea basin, we've built mature assets that something could do with this. We do it with compressors, but can the same things you're talking about be applied to existing stuff? Or
Yes.
is it all from the...
Well, actually, that example our very simple example was a pre-existing asset.
Okay.
So you didn't have to start from day one. You just have to you'd have to do a pretty good inspection to understand where you are day one.
Yeah.
You know, a lot of work that's going on in relifing assets at the moment wouldn't be anywhere near as onerous if this had been available 10 years ago, because you'd have a pretty good idea of where the asset was now. And that, condition-based monitoring would have done the same thing. The difference here is the ability to roll forward and gameplay, because you can take engineering rule of thumb, you can take the measured data from the asset, you can take like weather patterns, let's overlay that, because that might be more severe. What would this storm look like if it came over this rig? What would it do to the assets? So that you can roll forward. It doesn't matter if it's what you have to have is a high fidelity model of it. In many cases, when we go in, the first thing we have to do is say, is your engineering simulation okay? Now, for offshore, you're often working, as everyone said, you're working to design codes. That means the assets have been designed at a level, there's simulation out there at a level that is good enough to do this. It doesn't have to be better than that. It just has to be good. It has to be reliable, because you're using it to predict, so it needs to be reliable.
Okay, thanks very much, Gary. Much appreciated.
Okay.
Neil, do you want to make your way to the front? If I could ask you to take your microphone off.
Oh yeah, steal the microphone.
Okay.
It always gets embarrassing when you go to the toilet afterwards.
Pass it on to you.
It's just warm in here.
It is
It's
warm.
very warm in here. All right. So this is the last presentation before we go to another break. And we'll be talking to us about digitalisation in asset integrity.
Is this switched on? Yeah, okay. Put that over. Right, afternoon everybody. Yes, right. There we go. Okay, right, so I'll kick off. So my name's Neil Pickering. I'm the Global Service Line Director for Asset Management with Bureau Veritas. I just know how to use this thing. And the what, sorry? Right. Yep. Okay, so the presentation is broken down into 3 parts. So the first is an introduction to Bureau Veritas and a part of Bureau Veritas which is called BVS, Bureau Veritas Solutions, and then I walk into asset management in the digital world and introduce you to Veristar AM3D, which is a digital twinning capability that we have developed within Bureau Veritas, and then the challenges addressed. So, introduction to Bureau Veritas. Anybody in the room doesn't know who Bureau Veritas are? Yes or no? Right? Okay, right. So, Bureau Veritas were founded in 1829, and they're a classification society by core business. So we classify ships, basically. But within Bureau Veritas, there is a marine and offshore division, and there is a industry and infrastructure division. Now, sorry, I'll just click this on. I need 3 hands. Okay, so big company, look like this, 140 countries, 400,000 clients, very diverse business, like I say. Not only are they in marine and offshore, but they're also in infrastructure, rail, buildings, schools, universities, hospitals, in terms of inspection, certification and testing. So, big company, 4.5, just short of 5 billion euro, 1,400 offices and laboratories, and 75,000 employees. So, not a small outfit. Okay. So, within Bureau Veritas, October last year, there was a decision made to create a thing called Bureau Veritas Solutions. And within that, because some of our clients have a little bit of a problem when you've got a classification and verification body, which is what Bureau Veritas do on a day-to-day basis, and then you try and bring in what we call collateral services, so you have a bit of a conflict of interest there. So Bureau Veritas Solutions was created to enable Bureau Veritas to sell in non-class services. So within BVS, these are the service lines that are there: engineering, risk, assurance, regulatory and asset management. That's circled because that's the bit that I'm responsible for within BVS. And like I say, non-class services is there. So what I'm going to do now is I'm going to play, we're going to walk into asset management in the digital world. And I'm going to introduce you to Veristar AM3D, which is part of a digital twin. But first of all, I'm going to play a short video. I assume the sound's on, is it?
Yeah.
If you could just play that for us.
You just click the right one again.
Okay. No. That's part of the presentation. Yes. Just need the sound.
In running an offshore energy operation. It's a tough job with plenty of challenges: operational, economic, safety, and just compliance. It's a balancing act of performance assurance with integrity assurance. You put your reputation on the line right from the start. But in truth, you can only know so much. Once it's out there in the middle of the ocean, keeping on top of it 24/7 is pretty much impossible. It's not impossible. Look at your asset at all times, in CapEx, OpEx, or ABEX phases. See everything, every nut, bolt, every wire, every socket, every dimension. Yeah? Whales in the middle of the ocean. Nice. Making that a reality would be good. Immediate reporting. Shareholders on my side. Imagine if you could get all that info at the touch of a button. On your phone, even. Make it a reality. It's pretty straightforward. Straightforward. Being in the middle of the ocean 24 hours a day, with all data, all KPIs on every aspect of your operation, fully transparent. You can't do that. You need a crystal ball, X-ray equipment. In some instances, you need a time machine. Drones, LiDAR. Unless you could create some sort of digital twin.
Twin intelligence. That's something we've a line that we've coined as a result of the work that we've been doing. So it's always good to have a little video in the middle of a presentation, I think. So I'll come back to Veritarium's 3D and back to that video later on. So the next part that I wanted to talk about was asset integrity management versus asset management. Quite often the two are inextricably linked. They're also mixed up in a sentence. But to me, asset management is quite simple. The asset integrity bit is very active in this industry, in the oil and gas industry, in many industries. But asset integrity management is about managing loss of containment and about managing structural failure. In other words, keeping things in the pipe and stopping things falling off. Asset management, on the other hand, is about return on investment. So the 400-500 offshore installations that are left in the UKCS, believe it or not, are there to make money. They're there to make profit. So the balancing act that needs to be struck between asset integrity management and asset management is one of maintaining. So excess focus on either one of those sides will result in a problem, either in integrity breach or in potentially a performance issue or financial loss. So, yeah, so that's what I wanted to just get into here there, right. Now then, so digitalization. So we're in the age of digital. We're in a digitalization world. We're in the fourth industrial revolution, whatever you want to call it. But it's here now. It's happening. So 4 decades I've been in industry. I've seen everything from I've been alive, which is sad to say, but from landlines to smartphones, computers to where they are today, and digitalization in terms of the speed of change now is incredible. So it's readily available. This is the other thing. So it's not about the tech. It's about what you do with it. So the technology is readily available today and now. And there's companies out there that do this for a living. Yeah. So what asset owners need to understand is it's not about the tech. It's about what you do with it. It's how you put it together to maximize the value to you. And what's valuable to you is not necessarily valuable to the guy down the road.
So you need to understand what it is you want to do with this technology. Because just doing it for the sake of doing it, because it's nice and sexy and flashy, won't necessarily add value to your business. So it's about processes and people and foundation and cost-efficient solutions. It's about empowerment of people. Slow. Digital tools must add value, like I say, so you must be able to bring them in and bring value to your business. Enables agile delivery, provides a robust platform for management, align project partners and supply chain. This is an interesting one, and which is what I'll get on to going forward. Transparency and approach of this is easily communicated, so it must be user-friendly. Okay, so the digital transformation at Bureau Veritas. So what happened? So in 2015, Bureau Veritas issued their digitalization strategy, as many other companies did around the world. And they decided to go and speak to a company called Dassault Systems in Paris also. And they struck up an agreement with Dassault Systems, who's very big in aerospace, defence, domestic appliances, automotive industry, and that's basically a software house. And they partnered with them and they started the process of testing and piloting a thing called Veristar Ames 3D. Now, Veristar's suite of tools is something that Bureau Veritas own, and there is a number of tools in that tool set. Veristar Ames was already available, but they took it into the 3D world by this partnership with Dassault Systems. So over the journey, and in 2017, they rolled it out to everybody and made it available and started to sell it as a product. So what is a digital twin? Okay, this is a great question, and this is a great subject for discussion as well, because it is not a 3D model. 3D models are not digital twins of an asset, right? They are 3D models, and basically 3D models usually enable you to get dimensions, mostly. A 3D twin, or a digital twin, sorry, is a mirror image of your asset as it is. So you look in the mirror on a morning, I look in the mirror and see this handsome face staring back at me, and I then think, right, I need to have a shave, right? So I have a shave, the reflection reflects the fact that I had a shave. So if you change something on that asset, it needs to be reflected in your digital twin. So how do you do that? That's one of the challenges. And, you know, there's plenty of data. There's oceans and oceans of data around. The problem is turning that data into information. So Veristar Ames 3D, like I say, developed jointly between Dassault Systems and Bureau Veritas. Bureau Veritas brought their experience and technical knowledge into the situation from marine and offshore. Dassault Systems brought the software technology and the capability to do it. Interestingly, in terms of the technology, the oil and gas industry in particular, which is where I've spent 30-odd years of my life, is a very slow adopter to technology. We're terrible at it. You look at other industries like automotive, aerospace, medical, they've adopted all of this stuff already. The cruise line industry have been using digital twins for years. The defence industry have been using digital twins of their assets for years. And as the previous presenter said, they actually monitor the performance of these digital twins in operation. So, you know, this is not new stuff. This is stuff that's already available. It's readily available. Nobody has to invent anything, and it's not expensive. A digital twin on this basis is less than 1% of the capital value of any asset. Now, if you look at what the potential in terms of what it can bring to your business, it pales into insignificance. But the thing about Veristar Ames 3D is it will sit, and we purposely, unlike the previous presenter, we purposely did not include any analytics into this twin. It would confuse it, it would make it different. It does not replace systems. It does not go into your business and say, right, you need to get rid of your CMMS, you need to get rid of your ERP. It doesn't do any of that. It simply takes data from the systems that you have and builds a digital twin, a mirror image of that asset based on the data. Now, that'll tell you two things. One, it'll tell you what data you don't have. So if you imagine the Death Star on Star Wars, when it was being built, everybody's seen the movie, bits are missing. You build a digital twin and the data's missing, bits will be missing, and you'll find out what data you don't hold. You'll also be able to take a judgment call on what data you've got too much of. But it will reflect right down to tag level your asset. So it sits in amongst whatever systems you've got. It will interface with whatever CMMS, any ERP, any DMS you've got. It will take in analytics. It will visualize analytic output as an input into the digital twin. And it will project out on a configurable dashboard. This one isn't particularly sexy, but it gives you the idea. You can configure that how you want it to look. So the challenges it addresses, and we've got proof of this. So everyday operational challenges are faced. How can I capture routine maintenance? Well, if the data's in your CMMS, you have a tag hierarchy, it will be reflected in your digital twin. You can configure the digital twin to tell you when your equipment's in backlog. It'll flash red, it'll flash green, it'll flash yellow with pink spots on it if you want it to. So you can capture the data. It is available on any device anywhere. So the guy on the asset can have a handheld device with the same information that the guy in Houston's looking at, the guy in Aberdeen's looking at, the guy in Australia's looking at. You can enable VR into this digital twin, so the guy in Australia, Houston, Paris or whatever can all be walking around the same module looking at the same equipment. You can open up a junction box, click on the junction box, it'll tell you all the information that's in your CMMS, your ERP, your DMS. It will show any files that have been attached to it, photographs, etc. It will show them. So how do I reduce my inspection? These are all daily challenges that any operations manager faces. I know I have for many years. I had to use a spreadsheet. None of this was available. And if it would have been available, my life would have been a lot easier. Can I rely upon the accuracy of my asset condition data to allow, plan and prioritise my decommission activity? There's also project management capability within the digital twin that allows you to schedule and plan shutdowns, turnarounds, interventions, etc. You know, any offshore turnaround is usually about a 12-month planning process. I reckon with one of these in play, you could probably reduce that easily down to 3 months. So, compliance and data sharing. How can I get the right information to contractors and service providers? Interestingly, if the digital twin is in play, we all put out bids and tenders to bits of scopes or whatever. They come back in, they have contingency, assumptions, the prices are inflated, they come back. You make a choice, you put out whatever your tendering process is, you put it back to them, and generally 9 times out of 10 the price that they're giving you is not the price that you end up paying. You have a digital twin that is available to the service suppliers, supply chain. They can walk around that asset the same as you can. You can walk around with them. And there is no excuses that the price they give you is the price that you will pay, because they will have all the information that you have right in front of you, and they can bid on the basis of that. How can I get the right information across the decision makers? So it doesn't matter whether you're the CEO or whether you're the technician on the platform. You're looking at the same data. You're looking at the same information. The CEO's dashboard might be different to the technician's dashboard, but they're still coming from the same information. How can I optimize compliance and regulation? Now, this is interesting. In the marine side of the business for BV, they're looking at digital classification of ships. Now, the number of interventions and visits required to retain and maintain classification is quite a number. So if there's a digital twin in place, either an offshore installation or a marine installation, why does the regulator need to go to it? Why does the verification body need to go to it? There is a real possibility that you could reduce. Now, okay, there's probably a point at which somebody has to go off and press the flesh and say, right, yeah, okay, this is real. But if you've got an accurate reflection of your asset as it is, why does the regulator or the verification body or the CEO, for that matter, have to go offshore and bother everybody and disrupt everybody? Just a thought. Moving on. So how can I build a digital twin? Well, you can build a digital twin from anything. If you've already got a 3D CAD model or some sort of 3D model of your asset, great. It can be translated into a digital twin. It has to be formatted appropriately, but it can be done. You can take it from PNIDs, flat joints, PFDs, isometrics, whatever you've got. The first thing that they do when we get an order is they sit down with the client and say, right, what information do you have available to us that we can use to build this thing? So it laser scanning, photogrammetry, CMMS, ERP, equipment, asset registers, etc., drawings and registers. All the information you have can be sucked into this and it'll be used to build the twin. But like I say, one of the things it'll tell you is what you haven't got, or what's out of date, what's not as built. Data sources, well, they come from everywhere. So whatever data sources you have available to you. So whether it's strength fatigue analysis, NDT data, maintenance data, standards, regulatory company or whatever, they can all be input and used to build this twin. And like I say again, it is all accessible on handheld tablets, smartphones, desktops, whatever. Okay, yeah, there is a real, I believe, there's a real high-end potential to reduce the maintenance and inspection costs on any asset. Now, okay, in the overall scheme of what it costs to run an asset, the inspection and maintenance and repair costs might not be huge. Just compared to your tax bill alone, it might not be huge, but at least it's an area that you can credibly reduce. And, dare I say it, you could reduce the number of bodies on your asset. I used to work for an asset manager in Shell, and he used to say to me when I ran his maintenance firm, he used to say, Neil, if you're not reducing the skull count on my asset, you ain't saving me any money. Because if there's 100 people on my asset, I have to feed them, I have to fly them, I have to pay them. Get rid of the skull count, and then you're saving me money. Don't come to me with maintenance optimization things and all that kind of rubbish. I want money off. So there is a real possibility, I believe, because we're working with a lot of ship owners in the marine side of the business on autonomous ships. Now these guys, ship owners are an even stranger breed than offshore asset owners, right? They're used to having a crew of maintainers and operators and all sorts of stuff. Autonomous ships could potentially take them to 3 people, a captain, a technology officer, and a maintenance guy, an engineer. That's put the shockwaves through the marine world. What? These bloody great big ships can be done with 3 people. So, offshore installation, whether it's a pre-crine asset like a Magnus or a Thistle, or a Cormorant Alpha or a North Cormorant, you get a digital twin in place and you can do real good things, I believe, in that space and say, right, we can now start making some real headway into reducing the cost of this thing. How do I make everybody aware there needs to be done and when? Fine, okay, this is about the dashboarding, but yeah, your ability to, there's no analytics in this. The analytics are inputs. So you do analytics wherever you do analytics, whether it's your condition-based monitoring, condition-based maintenance, whatever, the inputs into this, it will reflect what you put into it. But what it does is it allows everybody to see the same thing and visualize what you need to do, and then you can start. If you've got analytics on the outside, it'll put it in, you start to get predictive analytics going in, it'll tell you that pump's starting to go from green to orange to red, you need to do something about it. But we purposely kept analytics out of it because it's just a step too far at the moment. So benefits, safety, no doubt about it. You've got new people going on your asset, you've got digital asset in place, your new OIM, sit them in the office for a week, say, right, walk around the asset, go and find out what you need to do. New technicians coming on board, shutdown squad coming on board, stick them in the asset, say, right, these are the modules you're going in, this is what you're going to do. Dollar efficiency, no doubt about it, it will improve. It will save money. Asset management, improve asset management and data through integrity and balance. Achieve that balance through integrity assurance and performance assurance. Reputation, don't doubt about it, it will enhance reputation. If you are becoming more efficient and productive and return on investment is going up, your reputation is going to go up. Accountability, demonstrate authority, stakeholders, assets, risk, condition management and user experience. Like I say, it's available on any device, anywhere, anytime. Your asset manager can be sat in the departure lounge at Terminal 5 Heathrow watching what's going on in his asset. Or her asset, sorry. So yeah, there's a whole heap of benefits. Yeah, okay. So where we're going next, I'm almost finished. Where we're going next, VR, AR, already mentioned it, is capable of doing that. Right? We haven't sold it to any clients yet, but VR, AR is well capable within this twin environment. Artificial intelligence has been worked on. So what they're looking at is drones being programmed to do the inspections, fire it back into the digital, the twin as it goes, and then the artificial intelligence is applied to that data, and machine learning starts to bring up predictive output. So who have we sold it to? This is the last one. All of these guys have bought it in various guys. Now, some of them are just hull and structure, some of them are hull, structure, and marine equipment, some of them are hull, structure, marine equipment, cargo handling, some of them are hull, structure, marine equipment, and topsides. So varying. couple of pilots were ran, as I said at the beginning, these with Total and Shell, they went very well. And the latest one we've just got contract awarded here is for 1 FPSO on buoy, which is ongoing, and 11 wellhead platforms and 3 production platforms. Interesting thing, none of them are in the UKCS. They're all outside the UKCS. So does that mean these guys are more receptive to technology or what? Last thing, yeah, so they're mostly Africa actually, well, Thailand and Asia. So yeah, we seem to be getting a far greater reception outside the UKCS than we do here. So, okay, I've been in this industry for a long time, most of it in the UKCS. We've got to change, we've got to start doing things different. And that's it.
Thank you very much.
Bang on time, I think.
Yeah. I think, to be fair, you started a bit later than you were supposed to.
Yeah.
So
Yeah.
that's not a problem at all. But is there any questions for Neil just before we split for a quick break? Yeah.
One question I have was, you're making it sound as though it's very simple and straightforward.
Mm-hmm.
When you flash forward to the contract process, you question mark that the digital twin or the use of the solution is on new build, whereas the
No, they're not all new builds.
right,
In fact, I think all of them, they were new builds, existing, and they were existing. So if we apply to brownfield, it's not necessarily good. The idea is to get it into the detailed design phase, and we have a client who wants to do that, get it in the detailed design phase of an FPSO build, but not to apply to brownfield assets. It's not just
so I'm not saying it's not. What I'm trying to tease out to you is just how much effort is involved in actually getting all of the information that you need to
Right.
create something actually.
As a benchmark, what the guys tell me in Paris, and I have to believe them, is it's 6 months to build a full-blown structured topsides asset. So it takes 6 months to build it. If it's a hull and structure, it's not 6 months, it's less if it's a full structure set. So a full-blown topsides asset is we are quoting six months to get it built. Now, like I said, if your information data is there, if you've already got a 3D CAD model that can be translated into the digital twin, that's going to reduce the time, obviously. 6 months, I think, is from flat drawings, and the same with hierarchy data, etc. Now, one of the other things that I want to say is we've got a proposal in with the OGTC, and Dawn sat there. We are looking for a donor operator because in the decommissioning space, like, you don't need a digital twin for a single wellhead riser, right? You don't need one. But for a Magnus or a Thistle or a Cormorant Alpha or a North Cormorant, you need them. So the lessons learned of Brent, and I work for Wood Group when they're doing the Brent decommissioning, and I was technical director in there, so I oversaw this project. The work they had to do to get to the point of starting the engineering work packs, because the data wasn't there to do the structural modifications, was incredible. It's cost a fortune. Digital twin in place, you're already there. You can just go in and say, right, what are we going to do with this thing? So the money, if there'd been a digital twin in place for that Brent asset, they wouldn't have had to do all that survey work. They've already been there. They'd be able to walk around and say, right, where do we do structural modifications?
Asking the question for me. In order to actually create that digital twin, that's going to be quite a significant investment. I mean, if you're looking at decommissioning an asset, is an operator actually going to want to go to all of the trouble of actually creating a digital twin once you take that plan?
Well, it depends at what point they want to do, because if you look at the Brent experience, the digital twin would have cost a lot less than all that survey work that had to be taken into play to get to the point of doing the engineering work. You have to create the drawings to do the engineering work. So yeah, and I get that. You know, there's a choice, there's a judgment to be made by the operator, the owner. Now they might say no, we're not going to do that. Right? But I believe there's value in it, because a lot of these assets still have some life left in them. There's value in actually, as you go into the end of life, late life, COP, there's value in having that because you can actually run your asset down a lot more efficiently with one of these in place than you can without them. So it's a judgment call. I accept some operators will say, no, they're not going to do it. But some will say, actually, no. You know, Magnus and Thistle are very complex assets. Right? They've been old-fashioned hookup, bits stuck on here, and over the years other bits have been stuck on. And you know, if you ever walk around Thistle, God, it'd take you a whole day to find your way around. So, you know, putting a digital twin in place in that when it comes to decommissioning has got to be a value, huge value in that. Right, we now see how we're going to take this thing apart. But it's up to the, again, I accept it's the asset owners.
I'm going to have to call the time because we're getting going again at 3:10, and you guys will probably want a quick cup of coffee. So, quick round of applause for Neil for a fascinating. Thanks very much, Neil.
I'll give you your mic back. Yes.
Yeah, thanks very much. Cheers. How are you doing? Are you okay?
Yeah, good. That's better.
Excellent.
Just noticed the clock's an hour behind.
Yes, we said that this morning.
Just now.
Yeah, it's not long. Not long. So grab a quick drink. You've got something. We should get some water.
That's okay. I think I might just need to do that.
It's going to be overlap.
There is what we do. So it is right. Where we find that there's something that's required that we don't do with our partners. But in the market at the moment, we've had independent market research. There are other products, but they're not. You know, this is technologies that catch you. You know, and it is relatively easy to build, right? But like I say, it'll tell you what information you haven't got. If your bit's missing, or if you know, when the guys on the line.
It makes me wonder if that's more the issue. Folk are feeling it will expose the state of the assets.
Yeah, but if the guy's on the plant and he's clicked on the junction box and he's about to go and inspect or work on, and he's saying, hang on a minute, that's not the same, right? So the data that's in the system is inaccurate in terms of what's in the box. We can then get somebody else to them and say, right, have a look at this. But then it tells you, right, we're not as built. And as you move into decommissioning, you have to be as built because you have to know where everything is. Structurally, from a decommissioning perspective and a process production system perspective, you know, where do you make your isolations? Now, in the decommissioning world as well, you don't need your production systems. You need life support systems, you need all that sort of stuff. You might need your major vessels because you might be using them for diesel storage or whatever you're doing in power. But all of that can be put into there. You think, right, okay, so what is a decommissioning? This is why we've got the word GTC, because I think the decommissioning model is that light, if you know what I mean. It's like it's the same thing but different version for a decom process. Now, like I said, a single wellhead riser, isolated, get a vessel and take it away. Thistle, Magnus, you can do that. Common Alpha, you can do that. Dublin Alpha goes out there. Do nothing. Because they can't figure out what to do with it. So, you know, so I think, like I say, it's in the age we're in now, what's valuable to one client is not valuable to another. And it depends on what they want. How they want it. This as a solution haven't got a fixed installation yet. That's what I'm desperate to get done. I said, right, I want a fixed installation, so we've now got 14.
Yes. Okay.
So,
It is very interesting, as you say. I think it's that balance between the maturity of assets, what they feel is the time and effort to get the benefit of these things. Because you can see once you've got it all there, you really are a winner.
Absolutely.
And you're speaking from voice of experience as well.
I mean, and like I say, you know, if there's a reasonable fee life left, you know, they say, right, okay, this is going to be the next 10 years, 15 years. Get away from this, because I genuinely believe you can start to optimise your maintenance crews, you can then make sure you've got the right people on there, shutdowns and turnarounds become a lot more doable, less expensive, you know, and it can really impact on the OPEX.
I think this is the bit, because I know everybody's doing that in their own ways, in their own sectors, and overlapping in different areas, but it's interesting seeing something that looks a much more interesting overlap with so many different areas that could benefit many departments, not just one specific sector.
Absolutely, supply chain, like I said, you know, you've got a digital twin in place, you put out a bid.
Or
no excuse for the supply chain to say, well, oh, we have to assume this, we have to put in contingency. No, go walk around it.
Being naive myself, to me the digital twin term felt fairly new, but you're right, it's in other industries for 15 years.
Well, Dassault, when I first went to see Dassault at their place in Paris, they showed me what they did for, I think, electrodes. They designed it, it's like the guy before, so they designed and built this washing machine, because electrodes was a different one. They ran it to destruction, overload, underload. They've done it for Renault, they do it for Peugeot, they do it for the defence industry, they're showing the defence industry, obviously all the cars, this is all competition. But, you know, these fighter jets have been monitored through a digital twin, and they say, right, get back to the airport, because because reputation-wise, if it crashes in the wrong side of a line on a map, they've got a problem.
I was going to say that F-35B went down in the jump back to see
yeah,
Japan, so they've got that one.
So these industries, they do anything.
So they're being
Why
funded.
is the marine and offshore industry not
I think it is done in phases though.
Yeah, it is.
It's initially, as you say, this digital twin will have done in a level at some point by various assets, and then of course people will go on familiar before you know it's almost forgotten.
But I think the way we've pitched this, the way the guys have pitched this, is good for the offshore industry, because it's not replacing anything. So you don't have to get rid of anything. It takes data from anything. It's not expensive.
So here we go up, but
huge amount of time.
to Emerson, then next, Emerson, then Exodus, then Blade.
Yeah.
Okay, that's not bad.
How are you doing?
Fine,
So I can get a bit of your colour.
there you may recognise if you're in the automation business. And underpinning that, we're adding our services and consulting line of business, so that's project engineering, project certainty, educational and life cycle services, and digital transformation. This graphic shows our PlantWeb digital ecosystem. So PlantWeb is the brand we have given to our digitalisation products and services. So this block here, this L-shaped block, is our traditional business. So Emerson traditionally manufacture best-in-class intelligent field devices. So that is all process related. That is flow measurement, pressure measurement, valve control, so process related instruments. We've always had device intelligence built in. So we've had intelligence and data around the devices whose primary purpose was process measurement. We've then got this tier, so into SCADA systems, control systems, product optimization. So this is how we've built up our normal solutions to date. As we're moving into the digitalization arena, we're going this direction. We're starting to add this pervasive sensing layer. Pervasive sensing it's a range of instruments now that their primary purpose isn't process measurement. It's more asset management. We're looking at measuring things like corrosion, erosion in pipelines. We're looking at measuring vibrating measuring around machinery health and diagnostics, external temperature, a lot of sort of ancillary measurements as opposed to the traditional flow, level, pressure and temperature. Security, that's been touched on today, and then what we've added here is these analytic packages that allow you to look at asset health, efficiency and performance, different applications for different needs and different drivers. Mobile data, so we're looking at digitally enabled workforce, so that's through tablets, phones, PCs, and following on from the last two presentations, digital twin as well. So that's part of the solution we offer around the digital twin business. And by definition, on the last presentation, digital twin, a twin by definition was born on the same day. So the data from day one needs to be in that system to make a good, solid digital twin example. At the top end, we've got consultancy and implementation support, and we've got the lifecycle services as well to complete the picture. So that is our sort of top overview of how we pool our products and services together to give this PlantWeb ecosystem. The Internet of Things, this was the promise of the Internet of Things. The last presenter gave us the model with its peak status has been around the last 5 or was it 10 years. So it's been at its peak there. But it was good. It offered real-time visibility, embedded expertise, sustained performance, and actionable information to anyone, any place, any time. So that is what the Internet of Things offered. The feedback we are getting from our customer base, from the market, is the biggest barrier to IoT adoption is making a clear business case. Now, one of the previous presenters touched on that. It's demonstrating this return on investment, justifying the expenditure and seeing a clear business result from the investment in the technology. There's a lot of nice, another presenter, sexy stuff out there that people want to get their hands on, but it's trying to build a business case around that as we are finding the number one challenge. I'm going back to our process control model here. So typically a process control is a closed loop process. So we've got sensors that will measure flow, temperature, pressure. They will feed that into a control system where we've got some intelligence, we've got some algorithms and control logic that will then decide whether to drive pumps, open or close valves, and then we assess the situation again, and it continues in this closed loop, making a measurement, taking executive action, deciding. So that is the process control part of the business. So if you apply this to asset integrity, reliability, safety, it's very often an open loop process. We don't have that closed loop process in there. A lot of the data is gathered manually. So whether that's by clipboards, whether it's by data acquisition, like portable handheld units, or just someone with cameras and various things, just gathering that data and feeding it back. They take that information back to an on-site workshop, a lab, send it to a third party for analysis, and then they decide on the next action. So it's very much open loop, whereas this model here is closed loop. So this is where our digital transformation starts. It's trying to make, using that pervasive sensing layer, so the non-process related measurements, we're starting to use these sensors so we can see the process. So we want to see what's going on in processes or within an asset or within a plant or an offshore platform. So we want to see that data. That data doesn't need to stay on the site. That can go to any world area, any off-site location to have the analysis done. So we can take that data, we can use the expertise where it exists. So we can take that off-site to make the decision. So we've got a see, decide, and enact sort of process. So we see the data, we analyse the data using experts anywhere in the world. We can use machine learning, we can use augmented reality, artificial intelligence. There are a lot of tools out there now to make sense of this data we're bringing in. Then we can feed this back to the coalface, back to the users to decide what they want to do with that, the results from that. So if you look at some of the previous presenters we're talking about today, if we sense that we've got a pump that's cavitating or the bearings are starting to fail, I don't know who was in the previous presentations, but we can identify or predict that's going to fail. We can send that, we can analyse that data off-site, and we could send that data to Andy Simpson in his 3D printing. He could send them a single-use PDF, so this is the future, and they could print that spare part close to where it needs to be. So that kind of model fits with what some of the guys were talking about today, in my view. It's, I can see how it all joins up. So that is the start of our digital transformation. Back to this slide just very quickly. As I say, this is the seeing part along the bottom. The analytic packages give you the decision part, and then this is the act, whether it's consultancy or service engineers, we can complete that circle. So we've got, as I say, the see, decide, act model built into that. So back to where I was earlier. The number one barrier to adopting the Internet of Things is making a clear business case with a clear return on investment. 60% of the people we talk to have an active Internet of Things digitalisation project in hand, but only 5% have got a clear business case to allow that to move forward. We're seeing different things from different users. We've got, at one end, people who have a problem here and now, and they want to know how best to solve that problem, and we've got people at the top end, at the corporate end, where they've got a budget to embrace this digitalisation message but don't know where to start. So we've got the two ends of the spectrum as to where people are in their digitalisation journey. What we're providing at the moment, what we've developed, is a tiered range of applications. So we've got the Plant Web Insight and Plant Web Advisor. So if you've had a look through the exhibition through the back there, Gary Lees is manning a stand where we've got Plant Web Insight. So this is almost like a base level asset specific pre-packaged application that allows you to see the health of that asset. So there's certain sensors and measurements taken, a pre-packaged set of analytics that allow you to assess that single asset. When you step up to the advisor platform, this then allows you to bring in additional information to check the health, performance, and you can start looking at energy usage. And this is when we start seeing bigger returns on investment. We start pooling information from PI historians, other databases to make sense or make more meaningful information. This is designed to be scalable, so to prove the return on investment, start at this level, and then you can start migrating once you've got that return on investment up to a higher end. And this is the same thing just in a different format. At the insight level, application specific. So these packages are designed to measure heat exchangers, pumps, fin fans, steam traps, pressure relief valves, application specific. Low cost of investment, quick return on investment. So it's low cost of deployment, quick return on investment, and it allows people to start building that return on investment or business case around deploying some of this digitalisation. As you move to Health Advisor, that's more of a site-wide application. We start looking at adjacent machines. So we'll maybe compare different pumps. We'll maybe compare pumps to the feedstock, because if pumps are misbehaving, they may be losing pressure coming from the head. If it's liquid, they may be losing the pressure coming through. So we'll start building up there. Higher cost of deployment, bigger return on investment, but a longer gestation period to see that return on investment. Taking it to the enterprise level, we're now starting to get into our operational certainty model, which is enterprise-wide, and that brings in the consultancy part of the business. And we're starting to look at real business drivers here. We're giving assurances on plant availability or site availability. We're starting to give tangible results in reducing the maintenance cost. So that becomes a far bigger sort of cost of ownership or a cost of deployment, but your returns on investment are far bigger. And this is moving into a top quartile arena. So if anyone's familiar with the Solomon report in the refining business, we're starting to move businesses into that top quartile, starting to meet the top quartile Solomon results that are driven. So that's, as I say, it's designed to be scalable. So entry level, once you get the comfort and see the return on investment, you can migrate to a higher end use. This was what I think the first presentation this afternoon touched on this about collaboration. As a process control and automation company, we're starting to find we're talking to a far wider range of people within a customer, within an end user. As we start looking at the digitalisation roadmap, we're getting involved in the digitalisation. This is a very real challenge that we see. We see a lot of examples in the North Sea, refineries, pharmaceutical, chemical business. We see this. There's a regulation that drives emissions to the atmosphere. It's driven by environmental issues. We need to identify any sort of releases to atmosphere. We need event duration, volume, and the type of release it is. So historically, we have spoke to the engineers on site. So we've had the conversation with the instrument TAs, engineering, piping, the engineering people. And their drivers are very much asset-based. So it's around that specific challenge at the time. It's around that specific asset. And the questions they're asking is what relief valve should be monitored? How do we get the information distributed? Do I need to get IT involved? So this is the asset-based conversations we've had there. We're now finding we're talking more to educational, health and safety, and certainly IT. So you've got the IT and OT conversations going on. Now, IT, they've got a more corporate, enterprise-wide questions they've got. Straight away, IT will be cybersecurity. Does it meet my cybersecurity needs? What's the goal? How does it compare to standards? What is the management? So they're looking at a far wider corporate sort of agenda than the asset-related person. But once we get our consultants and our advisors involved, we can start coordinating this and aligning the conversations. So our OT people still have the same questions they need answered, but we can then start aligning with IT. So we can give them the confidence in cybersecurity. We can give them the network infrastructure. So our network architects can start designing a robust network for the solution. So we start aligning that, and that's when we really get an understanding of strengths and we start achieving some real goals and objectives. And this is the outcome that Gary's demoing next door. It's a pressure relief valve, vibration sensor on here, and we've got this system health monitoring that will give them the frequency of releases, the duration of releases, and the volume of the release. So it measures all that, and green is obviously good, amber needs attention, black needs, or red needs urgent attention. So that's how we've set out the stall. So this is the last slide. In terms of operational technology, we've got the broadest portfolio in the industry. Emerson, I've got the widest range of intelligent devices, intelligent transmitters, so we're quite comfortable with that. We've got our solution architects and advisors that can join IT and OT together and can start having these conversations around network topology, cybersecurity, and start building that business case around there. We can't do it all on our own. So we've got a wide range of products. We can't do it on our own. There's companies here that specialise in networks, specialise in cloud hosting. So we've partnered with some of these companies so we can provide the complete solution as a business user. So I'm going to run a video here around Microsoft Azure, and it's where we partnered or collaborated with Microsoft and Chevron to provide this type of solution. So if the video is hooked up, I'll let. You got it. That's strange. It was working earlier. You had it. So. Did he leave it as a? Did he leave it on the desktop? No.
Yeah, I think he did.
That's it there. Oh, back to the desktop, right in the centre. That one, I think. That's the one that looked like the buildings behind. This is us. Right, we've got sound.
We have employees working across 100 different countries. All of them are working tirelessly to help those communities and people deliver the energy that enables human progress. Partnerships are a core business value for Chevron. At the heart of all of that is our vision to be the global energy company most admired for people, partnerships and performance. So we strategically look for partners who share those values. In October last year, we signed with Microsoft as the premier valve supplier for Chevron, and we've had a long-standing partnership with Emerson. The aim is to leverage their technical solutions to answer our business problems and succeed together.
Emerson provides complete automation solutions for industries like oil and gas, power generation, pharmaceutical manufacturing. We provide sensors, control valves, control systems, optimization software that helps those plants run safely and to their optimal production. And these solutions are appealing to customers looking to improve their operations, increase their safety, improve reliability, and want to do that through the adoption of new technologies. When it came to working with Chevron, Microsoft was a natural choice because they've built a lot of great technology into Azure, specifically targeted industrial IoT. Chevron had a lot of sensors and a lot of data around controlling their facilities, but needed a lot more data on reliability and energy consumption. That's where the plant web digital ecosystem comes into play. It is the core set of technologies Emerson deploys to develop new solutions for our customers.
For our first pilot with Emerson and Microsoft, we piloted the heat exchanger health solution at one of our refineries. We used Emerson sensors and gateways to connect the data from the field to Microsoft Azure to allow us to perform the analytics. Within Chevron, we've got more than 5,000 of these heat exchangers. And if we can understand the health of these units, it can help prevent unplanned outages, as well as reduce the number of scheduled repairs. And that can save you millions per year. While this pilot targeted heat exchangers, the underlying IoT technology can be applied to many other pieces of equipment. That's the whole value proposition around IoT.
Our best customers are becoming our best partners. And a great example is Microsoft and Emerson working together to help customers like Chevron going from concept to operationalized state in just days. Microsoft is investing $5 billion in this space, and we're leading the charge of simplifying IoT to make it easy for any enterprise to be able to benefit from it very, very quickly. We're so excited to be empowering our customers and partners to achieve so much so quickly and be leading this next wave of computing.
Okay, so that was just a summary, as I say, of a real example. We worked closely, collaboration with Chevron and Microsoft to give the cloud hosting for that. So that's pretty much me. So we went through the plant web, delivered our operational certainty model, and what we're aiming to do is show some ROI within IoT, and that's our objective here. So thanks for your time. I know it's been a long day. Thanks for staying and listening. Hope that was of interest. Hope that was of use to you. Happy with any questions.
Yeah, if anyone got any questions. Okay, well, thank you very much, Gary, for
Thank you.
Apologies, we're running, you can probably tell, about 5-6 minutes behind. If you want to come up. Just to remind you as well, if you do have questions, I've probably said this a few times, but I forget who I've told it to. We've got a different audience now. If you can download the guidebook app and scan the QR code, you'll have access to everybody that was here today, contact details. If you do have any questions and you want to get in touch with them further down the line, you can do. Okay?
Right.
You got the, that's the...
Oh, clicker.
The right,
that way?
top
Yeah,
right.
top. Yeah. There we go. So I'll introduce myself to start with. I'm Cameron McQuarrie. I'm the Innovation Manager with Exodus Group since the start of this year. My background is engineering. I'm an engineer. By degree, I'm an electrical mechanical engineer a long time ago. I then worked in tech safety in oil and gas for a few years, and then when Exodus started in 2005, I joined in the very beginning when it was about a dozen people. And quickly evolved into being a process engineer and field development engineer, partly because we were so small. We needed a process engineer to work in a field development job, and it was kind of, you were thrown in the hot seat straight away. So my background has been very broad in that sense, in terms of I've touched on quite a few different disciplines and got to especially through field development, work with a lot of people that do things that I don't know so much about and learn from them. And that sort of integration of disciplines and understanding is something that's been really a focus for Exodus since the very beginning. Integration has always been part of our branding, really. If I jump on. Exodus itself, for anyone that doesn't know us, we've been around for a while now, so we kind of assume that everyone knows who we are, but maybe that's not the case. We're a consultancy that covers the whole kind of life cycle of an oil gas development, or now expanding into offshore renewables as well. So that's from the very, very early sort of appraisal stages, and select and pre-feed. That's something that we've always had a very big focus on, that value-adding piece up front. Detailed design we don't really touch on so much, but in operations, we also can do any op support, any optimization, asset integrity management, vibration management, and we cover a whole big range of disciplines, from subsurface and wells, subsea, flow assurance, process engineering, facilities engineering, vibration. So it's slightly difficult to see what the exits do, because it's really easy to just go, just do everything. Like I said, I've been the innovation manager with Exodus since the start of the year. It's a new role for Exodus, but that doesn't mean we've not been doing innovative things since we started up. And we're just, I guess, doing it a bit more deliberately. We're putting a bit more investment in behind it, and we see that we need to do that to deliver what our clients need, to keep up with the competition, to do different things. So that's the whole reason for the job I'm doing now. This is just picking up on where some barriers typically are for innovation within companies of any type. This is something that was reported in the OGTC report on specifically talking about uptake of data analytics technology. That identified a number of barriers, and there's more detail behind these. So technical, cultural, commercial, awareness, and people, the themes they picked up on. The technical one is far and away the easiest one to break down, because you just need to find the technology. Someone will have it out there, or it can be reinvented. The cultural, commercial, well, you need some cash. But the cultural awareness and people sides are the ones that are much harder to break through, to make sure you've got that company culture that supports innovation. So how does integration, as we see it in Exodus, help innovation? And that's the kind of thread I'm going to talk about. It's not too much of a sales pitch type presentation, but I will mention some of our services and our products as I go through. And what do we do? What do we think we do well to help encourage that to happen?
So we have always worked with typically quite small project teams that can be formed as needed for client needs or consultancy. So we get a lot of different projects come through the door. We don't know what the next one necessarily is going to be, so we've got to be able to respond to that. And we don't know what's going to happen as that project develops. So particularly in the appraise select type phase, you can be jumping all over the place with your concepts. Where you think you started off on might not be where you end up, or you might need a very specialist piece of, there might be a risk that can be mitigated with a particular technique or particular specialism you couldn't anticipate at the beginning. So you need to be able to be agile. Before this became a buzzword, this is what we've always done. We've had to do it to satisfy what our clients are looking for. We were kind of whole reason that we were came into being was to bring initially subsea flow assurance, process engineering into deliver an integrated field development capability. We see that the benefits of bringing these disciplines together. Sometimes you'll get a field development job where the subsea engineering will be done by one lot of people, the flow assurance by someone else, and the topsides host mod type work by somebody else altogether. Bringing these three together brings value not just through efficiency. It's obviously more efficient to have all the people sitting in the same place, speaking to each other all the time. That's a easy, quick win. But you can also come up with better solutions because you're understanding much more about what the guy working on the other part of the project is doing, and you can spot those opportunities to create value. And for me, having moved into an innovation role from a field development role, there's a lot of similarity. You're trying to create value, you're trying to spot problems, and you're trying to find the solutions to solve those problems. One thing that's been a differentiator for us from some of our competitors is that we've had a software engineering capability from the very beginning of Exodus. That we have developed all our own business management tools, and we've developed a number of software tools that we sell to clients. And that's something that now that digitalisation is becoming this sort of great force moving through the industry, which is a really good place to be able to take advantage of that complete offering that we can put across. That all sounded a bit salesy. I said I wasn't going to talk about salesy, but so this big colourful wheel kind of represents all the various disciplines we've got. There's a whole bunch of other small specialities in there. But yeah, since the beginning, when we maybe touched on 3 or 4 of these, we've just expanded and widened out that capability to bring in a more and more complete picture. And what we're able to do is pick the right people from those different disciplines and pull them together for a specific requirement for a project or to develop something. So this is our bread and butter work, integrated field development, where we can pull in subsurface, we can pull in wells, we can pull in process facilities, flow assurance, subsea pipelines, and any other disciplines we need, and develop that as a completely integrated team with our client as well. And really make sure we're getting the most value in that. Similarly, if we've got bringing together process, production assurance, and our technology people, we can develop tools using data that our clients have, using some of their systems, their dashboarding type systems as well, and add a level of intelligence by our knowledge of what to look for. So compressor degradation, we understand how compressors work. We know how to turn the data that's out there into something that will tell you something useful about what you should do or when you should do it to pick up on some compressor degradation. And we can do it for a fraction of the cost that the vendor will try and sell you a system to use something similar for. And because we're out there, and maybe in the ops side, our process engineers, we can hear the problems our clients are having and put something together bespoke at the time it's needed very, very quickly. Another Another application we can bring together is using our geospatial engineering capabilities, GIS, our knowledge of what is interesting to the industry, pull that together and create things like dashboards. So this is something we put together just to do some internal analysis and 30th licensing round to who's bought what, put some of our own knowledge on there about what kind of company they are, what are their drivers going to be, that sort of thing. We've also done something very similar, which if anyone wants to come and speak to us at our stand, we can show you live, which has used PPRS data, so the production portal reporting for the OGA that has all the field production, oil and gas data, water injection data, put some rule sets to that to match it up to estimate the power use, and then we've mapped in a GIS environment what the power requirements are offshore. So if anyone wants to go and put a wind farm somewhere, then there's lots of power being used here or up here, and you can kind of see it. But again, those are things that we can just do, throw together very quickly, because we've got the people that are close together. Another area that's been a big expansion for us is in integrity management, and we've developed a asset integrity management, anomaly management software tool to help with that, which we always sort of deliver as a service. And that's a good example of us hearing a problem. So a subsea guy heard that a client had an issue with how they were already doing things. He was able to go and speak to the right software engineer in our technology group, see if, what would it take for us to put something together to solve this problem, do it really quickly, and then it's been adopted in client. They're using it all the time. We're using it for our integrity management service we provide as well. And again, it's quicker and easier to put these things together than a lot of people realise, and they can be simple and bespoke to just what the operators are needing. So for us, what makes these? How do we make integration work and drive that innovation by connecting up the problems that we see from our people are out in the domain, if you like, with the people that can solve them in new and different ways. So I've got 3 C's here. So competence. So here I'm talking about we need people that know, that can spot where the problems are, that have the real knowledge of the domain of the process engineers that really understand what they're doing, that have the expertise of technology that's out there, technologies that can be used, and can spot when there is a better solution to this is the way we've always done it kind of standard way of thinking. Curiosity. So we need people that are willing to go to, that are all the time thinking, what do, you guy that sits 3 desks along from me that does something different, and be interested and ask questions to get out of that silo. So I imagine the oil and gas industry is not the only place that has this, but there's a real temptation for people to be branded as a type of engineer in particular, and then never get out of that little box. Because we are, well, we're not small, but because we're not a massive multinational oil company, everyone can know everybody else. Everyone can know what everybody else does. Enough to speak to people, to find out what they do, and to understand a bit, and we can share. But we also need to give people a bit of time and a bit of space to ask those questions, to find out things, to use that curiosity to expand their knowledge and look for new solutions. And communication and collaboration. So communication is like, I think it's a big problem for everyone. It's always hard. It's hard to force, and you've just got to keep pushing people and reminding people. A lot of people are very shy to tell people what they do when it's like an amazing, clever thing they've done. The more people can tell and share what they do, is not just waiting for people to come and communicate to you to get out to them, and understanding problems that are out in the industry, listening out for that, understanding client problems, speaking to clients, understanding the problems we have internally in terms of like process efficiency type things, And then collaboration, you know, we play nicely with people, work nicely with people, bit of trust between companies, between us and operators. All are the cases where the new and different things we've done have worked the best. I think that's my last slide. Are there any questions? Thank you for listening.
Thank you very much. That was a fantastic presentation.
I'll not walk off with the microphone.
That would be grand. Thanks very much. So we have one presentation left. Brave man would like to stand up and come forward. So we've heard a lot about various innovations in technology. Stephen Leishman's going to talk to us a little bit about how to fund a lot of the technology and innovation that's been going on within the sector this afternoon, especially for the using R&D tax credits.
Let's see, help.
What a lucky bunch you are to talk R&D tax relief at the very last thing of a day. So thank you very much for your time. I hope this is of some use. I don't really echo what Karen said there. I don't want this to be about Leighton and so on, but I thought it would be useful to give you a bit of background as to who we are and ultimately why I suppose I'm standing here in front of you guys delivering this talk. For those who aren't aware, Leighton, we are formed in 1997. We're a specialist R&D tax consultancy that helps our clients access R&D tax relief, grant funding, patent box, research development allowances, etc., etc. Our goal is to help our clients grow. And how we do that is by accessing funding that's available to them, earmarking that opportunities for growth, rewarding that back to the client and letting them going on to do their next stage of development. We were formed back in 1997, as I say. We now operate in 11 different countries. We have just over 1,000 staff within the group. Essentially any country which offers R&D tax relief, Leighton has a footprint. The only one we don't have yet is Australia, which I'm sure if they said we were going to open, they would have a clamour for people sticking their hands up. But we have 23 offices throughout the globe. R&D tax legislation tends to be fairly similar throughout the world. But the methodology by which companies go about it is slightly different. The rate of relief is also slightly different. Some clients that we work with in some sectors, we help clients of all shapes, of all sizes, in many different sectors. So we will work within technology, we'll work within engineering, construction, science, in Scotland, software as well. In Scotland, we work with everything from agriculture and farming right through to oil and gas, clearly. Some of our oil and gas-based clients, four of which, not of these clients, but four of our clients are out exhibiting today. For those who aren't aware what R&D tax credits actually are, it's a scheme, but it was introduced by HMRC back in 2000. Simply the government's way of trying to encourage and incentivise innovation. You know, if you think about what the government try and do to incentivise other types of behaviours, you get tax relief on contributions towards pensions, you get tax relief if you save into an ISA, for example. R&D tax relief is another mechanism by which they are trying to incentivise companies to invest in innovation, ongoing growth, product development, service development, etc., etc. They're terrified of losing skills and innovation out with the UK. So this is a mechanism by which they're trying to retain talent in the UK and ultimately fund that ongoing development on an ongoing basis. The way that it works, it's a purely retrospective basis. So companies look back over their current year and 2 prior years, assess what costs have been earmarked or spent on development. Application is made. If approved, the rate of relief is between 25% and 33% of the cost that was spent. That's either paid as a cash credit or paid as a reduction in corporation tax. Doesn't matter whether a company's profit or loss. Clearly, if it's loss making, there's no tax to be offset, in which case it's just a cash benefit. The government are banking on the money that's reinvested or awarded, being reinvested back into the company itself. So the question we're asked quite a lot is, what's the catch? Because you get nothing for free in this world, clearly. The government don't do this out of charity. They don't do it out of the goodness of the heart. They do recognise that it leads to ongoing development. But ultimately, if a firm gets back 50,000, 100,000, 500,000 pounds, whatever it happens to be, that money is going to be reinvested in the form of new staff, new equipment, new orders, in which case it's more VAT, more NI, more PAYE, and it's that positive cycle that they're trying to encourage. When we did some analysis, this is for year ending 17, year ending 18, numbers haven't been released by HMRC yet. Year ending 17, there were just shy of 40,000 claims made for R&D tax relief alone. HMRC paid out £3.4 billion that year in R&D tax relief. What's alarming to us at Leighton, and especially the guys who are based in our Glasgow and Edinburgh offices, is that almost 50% of that went to London and the South East. If you look at what Scotland are claiming as R&D tax relief, we're coming in at £175 million, or 5% of the payout. Every single day, we meet with companies who are innovating. They are developing new products, developing new services. They're taking existing technology and adapting it to suit a current requirement or problem. We don't see this uplift being recognised in the innovative stuff that's happening in Scotland. The 18 numbers we expect to be different because I think there's more awareness about R&D tax. But personally, it's still going to be extremely low compared to what it should be, based on the innovative companies that we talk to every single day, and just a few examples that are here today. So what actually is R&D? R&D takes place wherever there is a new product or concept development. Quite clear cut, something doesn't exist, we develop it, there has to be an R&D project undertaken. But it also comes in the form of a product or concept enhancement. So what you sometimes find is that a lot of our customers, and a lot of this has been spoken about today already, is a collaboration in taking existing products and making them fit a particular problem. So we have a number of customers, for example, who might machine components for aerospace or F1. We then need to work out how we are going to make that component fit when we're dropping it down however many metres under the seabed, under the subsea, sorry. There's challenges faced with that: longevity, harsh environments, tolerances, etc. We need to work around that. So R&D doesn't just take place when something is brand new and we're inventing Google, or the new Google, or we're reinventing the wheel. It takes place wherever there is an enhancement or an improvement made to an existing piece of technology. Software development's a big one. And again, what you tend to find within software development is companies who claim on R&D tax, claim on the new development and the new coding. What actually miss out on is all the open source code that they're working on, the integration challenges, the latency issues, etc., etc. Often companies actually overlook their internal process or their manufacturing improvements. One of our clients is a large food production company, and they managed to double their output. And that wasn't just by leaving machines on overnight. Clearly no R&D, lovely, but they worked out how to increase efficiency, reduce waste by their internal process that they went through. Testing, prototyping, and also on any failed projects or investigative work. R&D doesn't just limit itself to something being complete or evidence that we have designed a new component. Actually, a lot of what happens out there doesn't even make it to that stage. Probably the biggest indicator of R&D is when something doesn't work. We need to work out why. So these are just, it doesn't have to be all of these. One of them will do, but that's a small selection of some eligible activities. Eligible stages, if you take a project in isolation, it actually starts right from the get-go. You know, pencil on paper, project description, feasibility studies. You then have the feed, obviously going into the engineering and design side, through to any prototype, testing, and finally through to manufacturing or production as well. R&D activity contained within each of them. You just have to look at each individual cost and time that's been spent on these proportions to work out how much is eligible for R&D. And the key word to HMRC is attempted. Again, it doesn't have to be successful, but it might be, I've put some examples up there to hopefully help paint the picture. It might be decreasing the weight of a component. It might be increasing output of a process or reducing waste. And again, it might be using existing technology for a different purpose. It's the attempted that matters to HMRC, and the stage that you're at when you go to make that submission for relief. So where did the costs come from? Again, not an exhaustive list, but it gives you an idea. Mainly, they're going to come from staff costs and those involved throughout those stages. They'll come from any subcontract spend that you have as a result of the project. If you do happen to hire any agency staff as well. Just to explain very briefly without getting too technical, the difference. HMRC, this will be your PAYE staff. Subcontract, their definition is someone who, as well as doing work for you, will be working for someone else at the same time. So you're acutely aware that as well as carrying out that piece of work for you, they've got other jobs on the go at the same time. Agency probably sits more akin to oil and gas, for example, which is, hang on, we've got some guys offshore that they're not on our PAYE, but they're offshore for 6 to a couple of weeks, whatever it happens to be. They're not working for anyone else, so they fall under that agency type staff. It's project by project basis, probably is the best way to describe that. You then have clinical trials and tests, consumable or transformable materials used throughout the project, any licenses for the design, and also if you have to give staff training on improvements that you found or issues that happened, can also be classed and included. Essentially, you have direct and indirect costs, which hopefully that paints the picture for you there. Essentially, you work around the costs, and that builds the basis for your qualifying expenditure. And essentially, whatever is in that pot at the end of capturing all those different costs, if approved, that's where the 25/33% comes from. It's whatever's in there. So, some misconceptions. Client-led work. So we have an awful lot of our customers, when I mentioned the £175 million that had been awarded to Scottish-based companies year ending 17. In the last 3 years, we're hired quite a lot by companies who are already claiming R&D tax. I would estimate a guess that probably 2/3 of our business is reviewing claims that companies have made themselves or with help from an accountant or auditor, for example. And the other third is from fresh claims. And what we've found is that in the last 3 years, our Aberdeen-based customers alone, we've returned an extra £35 million to those clients on top of what they had already been getting back. Now, how did we do that? Well, our business has been born out of a better way to do things. So if you take one of the challenges that companies face when they come to do an R&D tax claim is a lot of the onus sits with the business internally. So someone from a finance point of view will come along to someone technical and say, I need to know the complex projects that you do. I need to know the innovation that you're carrying out. And the challenge there for someone technical based or an engineer who's maybe been doing that for 5, 10, 15, 20 years is, where do I start? Actually, a lot of what you do day to day will feel routine if you've been doing it for that period of time. The legislation is 840 pages long, so companies are a little bit sceptical, a little bit unsure as to, well, how do I qualify what I do for R&D purposes? So where we come in is on the one side of our business, we have a team of tax consultants who are chartered accountants, tax advisors, specialising in R&D tax. On the other side of our business, we have a team of technical consultants. And so these are data scientists, oil and gas engineers, process engineers, software engineers, etc., etc. And what that means is we can have that peer-to-peer conversation to help and proactively identify the eligible R&D activity from those projects for our clients. Reduces burden for them, also makes sure that nothing is missed, massively increases their eligible R&D activity because we are educating them on what is and what isn't R&D throughout that process. So client-led work is often overlooked, and that's a huge proportion of a misunderstanding that I'm paid to do the work, so therefore how can I claim relief on it? There's no financial risk. True, if somebody's paying you a time and materials basis, if it's on a fixed rate, the risk is absolutely with the client, because if the project runs over, I'm hit for it. I can't go back and ask them for more. I could ask, but they might not. If companies had grant funding, you can still claim on R&D tax relief. On the grant funding itself, you just get back less. So rather than get back the 25 or 33%, you actually get back 11%. But you're still eligible for it because you're doing eligible R&D. Again, go back to the point there about classing work as routine. day-to-day problem solving is just deemed part of the job. It's what we've done, it's what we've always done. How can that be innovative? Again, if we're talking about increasing output, reducing waste, enhancing an existing product, you know, there's feasibility, testing, design that has to go into that process, a lot of uncertainty, and that's the uncertainty that HMRC are looking to reward in this case. Yeah, common misconception, one that's maybe overlooked, is internal developments. So improvements within a firm's own business. Quite often companies will look at, rightly so, what do we do, what's our service, what's our product, we'll claim on that side. Actually, hang on, how have we made our own business leaner, more efficient, better in some way? And subcontract work, obviously. Again, there's a grey area between whose R&D it actually is. Essentially, the way that it works is your costs are your claim, your subcontractors' costs are their claim. HMRC capped this at 65% anyway to allow for some crossovers, but to make sure it doesn't go too far, because there's always that element of, hang on, that was our idea. No, that was ours. But essentially, because it comes down to what's in the year-end accounts, it's there in black and white for them to look at what was spent on that project. So it's going to be quite clear-cut for them. And then you have all the indirect costs, the consumables, the software licenses, the travel, etc., which goes into that particular project. Not all of that is going to be, you know, you can't claim 100% of that clearly, because it's not going to all be 100% R&D activity. You just need to look at the eligible proportionments to find out what is. So as an example, design engineers would typically be 50% R&D. Time served experienced engineers would typically be 30%. Manufacturing, production, typically 15%, 20%, something like that. Software development much higher, because a lot more uncertainties, a lot more challenges around integration problems and lack of code or complex code, latency, project overburn, etc. So you tend to find that that's maybe 65%, you know, eligible for R&D activity. But you have to look at project by project basis to understand what you can and can't extrapolate out from that. And ultimately, it's one of the services that we assist with, is that education and helping to identify what can and can't be included. Often, and especially with a lot of our oil and gas clients actually, R&D activities which happen out with the UK, the activity might be going on offshore, it might be going on over in Norway or Houston. If it's paid for out of the UK, from a UK P&L, from a UK firm, that's the UK company claims on it. That's what HMRC are looking at. Who's paying for that activity? Doesn't really matter that it's happening out with the UK. Sitting alongside, I'm not going to read all this, but sitting alongside R&D tax relief is something called research and development allowances. R&D tax relief is for the P&L costs. That's all the OPEX spend. R&D allowances sits with the capitalised spend. So essentially, it allows companies to benefit from any capitalised costs that they have incurred throughout that project. It's slightly different from annual investment allowance, which is capped for a start. RDA is not capped at all. And you can also include things under RDA that you can't include under AIA, like cost of buildings, cost of machinery used throughout that project, for example. So rather than a benefit over the amortisation or depreciation period, you get a cash benefit. Pros and cons, but you know, sometimes companies are looking for that initial cash outlay to then fund ongoing development. Patent box is something which I thought might be worth just throwing up there to let you know a little bit more about. Quite a simple scheme actually. Any company which sells a patented product, has exclusivity to sell a patented product, has products incorporating a patent or bespoke parts of a patent, they license out patents, or they are earning income from infringements or penalties of a patent, simply get the revenues from any of them subject to a flat 10% versus the standard 1920. Again, paid as a cash credit or a reduction in corporation tax. I'm pleased to know that was it. Any questions at all? I don't know if I've got time actually for a couple of questions, if anybody has any.
Do you have a presence in Aberdeen?
Yes.
Whereabouts?
Oh, sorry, office space? Yeah. No, sorry, no. We don't have an office space in Aberdeen. We have about 117 customers up here now, which we service from our four UK offices, which is London, Manchester, Glasgow and Edinburgh. We terms of our business, our UK team is about 200 now. And you can guarantee that any one time, any particular week, there's a team of us here. The intention was, when they opened the Glasgow office 4 years ago, so London was head office at the time, and I think the company was very guilty of being very London focused. You know, you can see from the number of claims that we're going through, 50% of them are sitting down there. So we kind of forgot there was a world out with M25. But they then recognised the gap in the market up here, and it was between Glasgow and Aberdeen that we were looking to open. And I think the company felt that Glasgow allowed us access to the northeast, but also into the northwest of England, where there was also unlocked potential. I've tried to strike both. Edinburgh has since opened because it gives us access to the software element to it. And actually, the client base that we now have and the activity we have in Aberdeen, we've done without having an office here. So it's not to say we won't have an office here, because we want to show our commitment to the region, and we want to show our investment, I suppose. But it's not something we've done yet.
Anybody else?
Sure.
So what's your cut?
Oh, so it depends on the way that the client wants to work. So some of our clients ask us to work on a fixed rate basis. Some of our clients want us to work on a contingency-led basis. I understand that because they want to mitigate risk. So to put it into context, we have submitted over 9,000 claims in the past 18 years with 100% success. So we're quite comfortable working on a contingency-led basis because actually we wouldn't submit if there was not going to be a benefit paid out. It depends on how much R&D expenditure there is. So some of our SME clients, we will have to charge 25-30% of their cut to cover our costs. Some of our larger organisations, you can imagine it's not going to be anywhere near that because they are talking 7 figures worth of relief. So very much depends on how much R&D benefit is there for us to cover our own costs and give ourselves a margin to grow.
And on average, so you gave quite a staggering figure. Was it 35 million extra in Aberdeen?
Yeah.
What does that sort of like work out on average extra that you managed to knock out of it? As opposed to somebody being claiming themselves.
Yeah. So they were claiming themselves. So the extra 35 million is on top of what companies who had been doing it themselves were getting. We got them an extra 35.
So what sort of like percentage?
Oh, I pass. I mean, sorry, I don't mean to not answer the question. Our average fee is probably somewhere between 15 and 20%, something like that, in terms of what the net benefit to our clients. But in terms of that extra 35 million, I couldn't possibly pull an average across. But yeah, that extra 35 million is not from companies who had never been claiming before. That's from companies who engaged us to say, you know, we think that we've been conservative, or we think that we've not included everything that we should have, and we've gone in and identified that extra 35 million for them. Yeah. Sure.
What's the minimum R&D spend below which it's not worth the while engagement?
Good question. Well, if you work it back, company was to get back, say, a profitable SME is going to get back 25% of their spend. So if a company had, say, £50,000 worth of eligible R&D spend, they're getting back in the region of 12.5. We would then charge probably something like 25% on that, 3-4K, something would be our fee. I'd probably argue that any less than £50,000 on that basis, it actually wouldn't make sense for the client to hire us, because actually, the project, if a project's only going to capture, or it's going to capture less than 50K worth of R&D expenditure, you're not going to need to identify much, if that makes sense. So don't use a sledgehammer to crack a wall, and that would be my argument. But in those scenarios, we do a lot of work with the OGTC or the OGIC, for example, and these guys won't have anywhere near that level of cost as yet, but we'll do a lot of education seminars with them and guidance and advice so that they can do it themselves correctly. And then, yes, as they grow, they maybe want to come back and use us in the future. They can use us as a sense check before they submit to HMRC. Because companies are quite fearful, understandably, that if they get it wrong, they're going to do one or two things. They're either going to massively underclaim and not benefit to what they should, or they're going to overclaim and they're going to get a chap on the door from HMRC to ask why. So it's about making sure that everything that should be included is included, but is fully compliant. Any less than 50, I would argue they could probably do it themselves.
And is the rate of recovery the same for pre-revenue companies as well as
Yeah.
those who are paying tax at the moment?
Correct. Yeah, absolutely. Yeah. Sure.
And to follow on the service, the training you provide to these small companies, is this free of charge or is that fee for that?
No. So the training we've given before has been free. As a business case, we look at it and say, actually, if we can help startups, who's going to be the next unicorn? You know, and you know that will help us in the future. But no, we've done that free of charge, absolutely. Yeah.
You run them around Aberdeen area?
Yeah. So kind of Aberdeen. We've ran them in Aberdeen, Edinburgh, Dundee, especially a lot around software gaming. You can imagine. But yeah, they kind of consistently happen. What we tend to find is a lot of our business comes from referrals, clearly, because the nature of our work, especially within our oil and gas-based clients, if I skip back very quickly, to a lot of our Aberdeen-based customers, it's operators, tier one, and further supply chain. So you tend to find that the R&D project will span probably 3 or 4 different companies, in which case we'll, introduction after introduction after introduction. And so when it comes to the seminars, we'll either run them in partnership with our clients who are looking at their own supply chain, or actually we receive a huge amount of work through accountancy firms as well, because accountants recognise the specialism not only in the R&D tax legislation, but on the technical knowledge. A lot of our accountancy partners, if you like, I don't like calling that because there's not that kind of financial benefit between the two, but in terms of them recommending us, they recognise that the technical team that we have in the UK, they don't have access to. So they would fully admit themselves that they wouldn't understand enough about the known and unknowns from a technical standpoint of their client's business to be able to really advise them and guide them. They'd probably capture the top level stuff, that's brand new, we'll include that, but what happens to the stuff below that? So we do a lot with accountants, premises and that type of thing. Hi.
Just going to ask of your client base,
Sure.
The service base within Aberdeen, how often does it go the other way where the operators are made very aware of their involvement and they will make a claim or be able to claim against that bigger players? Is that quite common?
Well, they can't claim on the tier one or subcontractors' costs because that's their costs. So the way that it works is you would look at your year-end accounts. We have a salary bill of X, and the projects that we have that are eligible for R&D amount to Y. That's what we're claiming on. There is an element of the subcontract spend for sure, but the way HMRC stop that crossover is 1, capping it at 65%, and 2, who has autonomy. So who has the financial risk and who has autonomy means that it's quite clear as to whose R&D it actually is. So you will absolutely find that within a project, you might have 3 or 4 different companies claiming on their element of that project. There's a small amount of crossover. HMRC are okay with that, but it stops it going any wider than that. It stops the bigger guys saying, no, we'll just take that, thanks very much. Because it's not on their P&L, it's not on their costs.
Okay. Any more for any more?
No. Great, thank you very much, guys. Appreciate that, thank you.
That's it. Just want to thank you all very much for coming along. This is our first event, OGV Innovate. There will be many more coming up over the next few years. OGV Energy ourselves like to think that we're innovating in as much as providing a new engagement platform for you guys to showcase your products and services to the industry. And I would say that after today, innovation is obviously very alive and well, certainly here in Aberdeen. So thank you all for coming, and hopefully we'll see you all again soon.
Thank you.